Somewhere in the mountains of southern Spain, roughly 40,000 years ago, a small group of people huddled around a fire in a cave overlooking the sea. They didn't know it, but they were among the last of their kind. Not the last humans, there were other humans, newer ones, spreading across the same landscape. But the last Neanderthals. The final flicker of a people who had survived ice ages, mammoth hunts, and hundreds of thousands of years of a brutal, unforgiving Europe. And within a few thousand years they'd be gone. Except, are they really gone? That's the question that's kept anthropologists arguing for decades. Because when you ask what happened to the Neanderthals, you're not asking about some clean, simple extinction like a meteor wiping out the dinosaurs. This isn't a story with one villain and one moment of collapse. It's messier than that, stranger than that, and honestly, a lot more human than that. For most of the 20th century, the story was told like a tragedy with a clear ending. Modern humans arrived. Neanderthals couldn't compete. Neanderthals died out. The end. Simple, clean, over. But the more scientists dig, literally and figuratively, the more that simple story falls apart. Because the truth is, the Neanderthals' disappearance took thousands of years. It happened differently in different places. Some populations vanished quickly. Others hung on in isolated pockets for millennia after their neighbours were gone. And through it all there was climate chaos, new arrivals, shrinking numbers, and possibly whole networks of contact, and even relationships that we're still trying to understand. The final 10,000 years of the Neanderthal world, roughly from 50,000 years ago to their last known traces around 40,000 years ago, were not a slow fade into darkness. They were a period of dramatic upheaval, ice sheets advancing and retreating, landscapes transforming from forest to steppe and back again. And into this shifting, unstable world walked a new kind of human, us spreading out of Africa and into territory the Neanderthals had called home for hundreds of thousands of years. Here's the part that still gives people chills. The Neanderthals as a distinct people, as a separate branch of the human family living their own lives, hunting their own animals, burying their own dead, did disappear. But they didn't vanish without a trace. Not completely. Because right now, today, if you have European or Asian ancestry, somewhere between 1 and 2% of your DNA came directly from Neanderthals. Every time you dream, every time you get sick, every time your immune system fights off a virus, some fragment of that ancient genetic inheritance might be quietly at work. They're extinct as a people. But biologically, in a strange and haunting way, they never entirely left. So what actually happened during those final 10,000 years? Was it violence, disease, simple bad luck spread across countless small, fragile populations? Or was it something slower and sadder, a kind of genetic and cultural absorption, where two human populations that could interbreed simply blended together until one identity faded into the other? We're going to walk through all of it. The climate, the contact, the DNA, the last known refuges where Neanderthals held on the longest. It's a story built from cave sediment, fossilized bone, ancient genomes, and just enough mystery to keep scientists debating for another generation. Before we go further back, though, tell me where you're listening from and what time it is right now. I love seeing these comments roll in. Tokyo at midnight, Toronto just after lunch. Somebody in Norway watching the sky get dark at 3 in the afternoon. It's strange and wonderful, this little global campfire we've built. And if you want to support the show, genuinely the best thing you can do is follow along on Spotify. Listen there when you're winding down. And if you're enjoying these stories, leave a 5-star review. The link's in the description. It helps more than you'd think. So let's rewind, because to understand how the Neanderthals disappeared, you first have to understand who they actually were before things started falling apart. And that story doesn't start 50,000 years ago. It starts closer to 400,000 years ago, maybe earlier, depending on which fossils and which dating methods you trust. Neanderthals weren't some strange evolutionary experiment that popped up out of nowhere. They were a long, deeply rooted branch of the human family tree, evolving gradually in Europe and Western Asia, from populations that had been there for hundreds of thousands of years before that. Their ancestors, sometimes called Homo heidelbergensis by researchers, though even that label is debated, had already been living across these landscapes, slowly adapting to conditions that modern humans wouldn't encounter in Africa. Cold winters, short summers, landscapes that shifted from forest to tundra and back again, depending on which way the climate was swinging that particular millennium. By the time you could call them Neanderthals, properly, distinctly Neanderthals, they'd already been shaped by that world for an extraordinarily long time. And that's really the first thing worth sitting with. These weren't a struggling, marginal offshoot barely holding on until modern humans showed up to finish them off. Neanderthals were, for most of their existence, a successful, resilient, remarkably adaptable population. They outlasted multiple ice ages. They survived climate swings that would have wiped out less capable populations entirely. For context, they were established in Europe long before our own species had even fully evolved in Africa. If success is measured by how long you managed to survive as a distinct population, Neanderthals were, by a wide margin, more successful than we've been so far. Now, let's talk about their bodies, because this is where popular imagination tends to go wrong. The old stereotype, the hunched, dim-witted caveman shuffling around with a club, has been thoroughly dismantled by decades of careful research. Neanderthals weren't stooped or shambling. They stood upright, just like us. What they were was built differently, and for good reason. Their bodies were compact and powerfully muscled, generally shorter than the average modern human, but heavier, denser, packed with bone and muscle mass that would be startling to see today. This wasn't weakness or primitiveness, it was thermal efficiency. A shorter, stockier frame loses less body heat than a tall, lean one. It's the same basic principle you see in modern human populations adapted to cold climates versus populations adapted to hot ones. Neanderthals had, over hundreds of thousands of years, been shaped by natural selection into bodies that conserved warmth in an unforgiving environment. Their faces tell a similar story. Large projecting noses and wide nasal cavities, which sounds like a strange detail to focus on, but it mattered enormously. Cold, dry air is dangerous to breathe directly into the lungs. A bigger nasal passage gives incoming air more time and surface area to be warmed and humidified before it reaches sensitive lung tissue. It's not a flaw, it's an adaptation, refined generation after generation by a climate that punished anyone who couldn't manage the cold efficiently. Their brains, and this tends to surprise people, were on average slightly larger than those of modern humans. Not smarter necessarily, brain size alone doesn't map directly onto intelligence, but larger, likely reflecting the cognitive and physical demands of processing a huge amount of sensory information needed to survive in a genuinely dangerous Ice Age landscape, plus supporting that dense, powerful musculature. The relationship between brain structure and intelligence is still debated among researchers, and we should be cautious about drawing simple conclusions either way. But there's little doubt anymore that Neanderthals were cognitively sophisticated in ways scientists once refused to consider. Their world, before the final chapter began, was enormous. This wasn't a small, isolated population clinging to one corner of the map. Neanderthal remains and their distinctive tools have been found from the Atlantic coast of Portugal and Britain, across France, Germany, and Italy, through the Balkans into the Caucasus Mountains, and eastward as far as Siberia near the Altai Mountains, thousands of miles from where their story began. That's an almost unbelievable geographic range for a population without agriculture, without permanent settlements, without anything resembling the transportation or communication networks we take for granted today. They lived through multiple, dramatically different environments within that range. Dense temperate forests in Western Europe during warmer interglacial periods, open, treeless steppe and tundra during the depths of glacial cycles, when mammoths, woolly rhinos, and reindeer dominated the landscape. Mediterranean coastlines in Spain and Italy, where shellfish and marine resources supplemented their diet. Mountain valleys in the Caucasus that required entirely different survival strategies than the river plains of Central Europe. Wherever they went, they adapted, which tells you something important. Whatever else Neanderthals were, they weren't rigid. They weren't stuck doing one thing in one place. They were flexible enough and clever enough to make a living across an extraordinary range of conditions. Their tools reflect that same flexibility. Archaeologists generally group Neanderthal stone tool traditions under the label Mousterian, though that term covers a surprising amount of regional and temporal variation. They used what's called the Levallois technique, a method of carefully preparing a stone core so that when you strike it, you get a flake of a predetermined size and shape, sharp, useful, and consistent. This wasn't random smashing of rocks. It required planning several steps ahead, understanding how stone would fracture before you ever swung the hammerstone. That's the kind of forward thinking we don't usually associate with the old caveman stereotype, but the evidence for it is sitting in museum drawers across Europe. They hunted large, dangerous animals, often in coordinated groups, targeting bison, red deer, wild horses, and in colder periods mammoths and woolly rhinoceros, isotope analysis of Neanderthal bones, and yes, scientists really can extract this kind of information from ancient skeletons, shows that in many regions their diet was dominated by meat, placing them near the top of the food chain alongside wolves and cave lions. But that picture varies by region too. Coastal populations show evidence of eating shellfish and possibly fish. Some sites suggest they gathered and processed plant foods as well, using fire not just for warmth but for cooking, which makes certain foods easier to digest and extracts more nutritional value from them. And they weren't solitary. The evidence increasingly points towards small family and kin-based groups, probably numbering somewhere between a dozen and a few dozen individuals, groups that likely maintained some contact with neighbouring bands for the purposes of finding mates and possibly exchanging resources or information. Some sites show evidence of care for the injured and elderly, individuals who survive for years with disabilities that would have made hunting or even walking difficult, meaning someone else was helping feed them, protect them, keep them alive. That's not just survival instinct. That's something closer to compassion, or at minimum, deep social bonds that we're still trying to fully understand. This is who they were before everything started to change. A successful, adaptable, geographically widespread human population, with hundreds of thousands of years of history already behind them by the time our own species even considered leaving Africa. Understanding that deep history matters enormously, because what happened in their final 10,000 years wasn't the story of a fragile, failing population meeting its inevitable end. It was the ending of something that had, by almost any measure, already succeeded beyond what most species ever manage. Which makes the question of what actually went wrong even more interesting, and honestly, even more unsettling. And the first part of that answer is the world itself. Because when people hear the phrase Ice Age, they tend to picture one endless frozen landscape. Snow everywhere, mammoths trudging through blizzards. Neanderthals huddled in caves while winter lasted for 100,000 years. But that isn't really how the late Pleistocene worked. Europe during the final part of Neanderthal history was cold, yes. Sometimes brutally cold. But it was also unstable. restless. A world that could change its rules within the lifetime of a single person, and sometimes fast enough that a child born into one landscape might grow old in another. The Ice Age was not one long winter. It was a pulse. Cold periods interrupted by warmer ones. Open grassland giving way to scrub and forest. Rivers changing course, coastlines moving, herds shifting their migration routes, following plants that had moved north, south, uphill, downhill, or simply vanished from a valley where they had been dependable for generations. And if your life depended on knowing where the animals would be next season, that was not an abstract problem. That was everything at the coldest moments. Vast ice sheets covered northern Europe. They pushed down from Scandinavia and Britain, locking up so much water that sea levels fell by more than 100 metres. The English Channel, which today separates Britain from France, was often dry land or crossed by broad river systems. The North Sea was not a sea in the way we know it. It was at different times a wide plain of grassland, rivers, marshes, and migrating animals. You could walk across territories, now under water. You could follow herds through valleys that no longer exist. You could stand on a ridge in what is now the coast of France and look out across a landscape stretching toward Britain without seeing open ocean at all. Further south, the world could be open and dry. Cold steppe, sometimes called Mammoth Steppe, spread across much of Europe and northern Asia. It was not empty wilderness. It supported enormous grazing animals, mammoths, woolly rhinoceros, bison, horses, reindeer, saiga antelope in some regions, and red deer where conditions allowed. Behind them came predators, wolves, cave hyenas, cave lions, humans. For a skilled hunter, open steppe offered opportunities. You could see far. You could track herds over long distances. You could anticipate where animals might cross a river, funnel through a valley, or shelter from wind along a limestone ridge. But open ground also exposed you. There were fewer trees for firewood, fewer natural materials for shelter, less cover when approaching prey, and when the wind came across the plain, there was almost nothing between you and it. Then the climate would shift again. Warmer intervals could bring trees back into places that had been treeless for thousands of years. Birch and pine first, often followed in some regions by denser woodland. Forests expanded, wetlands formed. Rivers became more reliable in some places and more difficult to cross in others. The animals changed too. Mammoths and reindeer were still present in many regions, but wooded environments favoured different prey. Red deer, roe deer, wild boar, aurochs, perhaps ibex in rougher uplands. A forest is not simply a greener version of the steppe. It is a different world with different rules. On the steppe, a group might scan the horizon and see a herd moving miles away. In woodland, visibility collapses. Animals appear suddenly and disappear behind trees. Hunting becomes a matter of reading tracks, broken branches, dung, feeding marks, the sound of movement in undergrowth. A large animal can be close enough to hear and still impossible to see. Woodland also offered things open steppe did not. Firewood, plant foods, nuts in the right season, shelter from wind. Smaller game, raw materials for handles, digging sticks, and possibly traps or structures that rarely survive in the archaeological record. But it could also divide the landscape into pockets. Dense forest, swamp, steep slopes, and tangled river valleys could make travel slow and uncertain. For Neanderthals, who probably lived in small groups and depended on a detailed mental map of local resources, these changes mattered constantly. A familiar hunting route could become useless. A cave that once overlooked a productive valley could find itself above a forest where the old herds no longer passed. A stone source used for generations might become harder to reach because a river had widened. a glacier had advanced, or new vegetation had made the journey longer and more dangerous. And the changes were not always slow. Ice core records from Greenland show that the late Pleistocene climate could lurch between colder and warmer conditions in surprisingly short periods. Scientists call some of these abrupt warm phases Dansgaard-Oeschger events. The names are technical, but the basic idea is simple enough. Temperatures in the North Atlantic region sometimes rose dramatically over decades, perhaps even less in certain records, before settling into new patterns. The exact effects varied from place to place. Europe did not transform overnight from tundra into forest. Climate is complicated, and local conditions mattered. But these shifts were real enough to alter rainfall, vegetation, sea ice, river flow, and animal distributions across huge areas. Then there were the colder reversals, periods when massive amounts of ice broke off northern ice sheets and entered the Atlantic, disrupting ocean circulation and changing weather patterns far beyond the sea. These episodes, often called Heinrich events, may have made parts of Europe colder, drier, and less predictable. Again, not every valley changed in exactly the same way. But for people living close to the edge of survival, they did not need the whole continent to become unlivable. It was enough for one crucial region to fail. One valley loses its deer. Another becomes too dry for reliable water. A mountain pass is blocked by snow longer than usual. A coastal route disappears beneath storms. A group that had expected to meet relatives at a familiar seasonal camp finds no one there, because those relatives have moved, died, or been forced onto another route. This is what instability means at a human scale. It means that survival was not just about enduring cold. Neanderthals were very good at enduring cold. They had done that for hundreds of thousands of years. The harder problem was unpredictability. You can build a life around a harsh but regular winter. You know when to gather fuel. You know where animals migrate. You know which caves hold snow late into spring, and which river crossings are safe after thaw. But what do you do when the winter arrives early or ends late, or the animals do not come? You adapt if you can. You move. You change prey. You range farther. You rely more heavily on food stores, if you have them. You strengthen ties with neighbouring groups. You search for new territory. But every adaptation carries a cost. More travel means more energy burned. Longer hunting trips mean more danger. Moving into unfamiliar country means competing with other predators and perhaps other Neanderthal groups for places they already know well. This is why some archaeologists think of certain regions as refuges. Not necessarily warm, comfortable paradises, but places where people and animals could persist when conditions deteriorated elsewhere. Southern Iberia, parts of Italy, the Balkans, the Caucasus, and sheltered river valleys in Western Europe may at different times have offered more stable combinations of water, vegetation, game and protection from the worst northern cold. But even the word refuge can be misleading. A refuge is not a place without problems. It is a place where the problems are slightly more survivable. And that distinction becomes important later, because the final Neanderthal populations appear to have been concentrated in some of these western and southern regions. Not because they had suddenly become incapable of living elsewhere, but because the map of Europe itself was contracting and rearranging around them. There is another complication here, one that makes this story frustratingly difficult to tell with absolute certainty. We can reconstruct ancient climate in remarkable detail, but not with the precision of a calendar. Ice cores from Greenland give us one kind of record. Cave formations give us another. Lake sediments, pollen grains, marine mud, ancient shorelines, and the chemical signatures preserved in animal teeth all add pieces to the puzzle. They can show when climates became colder or wetter, when forests expanded, when grasslands retreated, when dust increased, when sea levels fell. But connecting those records to a specific Neanderthal campfire is much harder. A layer of charcoal in a cave may be dated to somewhere around 45,000 years ago, but with a margin of uncertainty. A cold event in an ice core may be dated on a different timescale, with its own uncertainty. A tool assemblage may represent a brief visit, or repeated visits over centuries. A cave can preserve thousands of years of activity compressed into a thin band of sediment, while another site may be missing entire periods because erosion removed them. So when someone says Neanderthals disappeared because of this particular cold snap, caution is needed. It might be true in part. Climate clearly placed enormous pressure on populations. But matching one environmental event to one human outcome is rarely as neat as it sounds. The evidence gives us patterns, not a perfect diary. What it shows is a world in motion. A Europe where the best hunting grounds could shift across generations, where open plains became woodland. Woodland retreated into pockets, and rivers, coastlines, animals, and people all moved in response. A world where Neanderthals had survived change many times before. But by the time their final millennium approached, change was no longer the only pressure building around them. The landscape was becoming unstable. Their populations may have been thinning in some regions. And soon, into this already shifting world, another kind of human would arrive. But that contraction did not happen all at once. There was no single year when Neanderthals woke up and found that half their world was gone. No line drawn across Europe, no announcement carried from valley to valley telling people that the north was empty now, that the east had become too dry, that familiar camps would never be used again. It happened slowly, unevenly, one region at a time. For hundreds of thousands of years, Neanderthals had occupied a vast territory. At different moments in their history, their range stretched from Atlantic Europe through the Mediterranean, across the Balkans and the Near East, and far into Western and Central Asia. Neanderthal fossils and tools have been found in places as distant as Portugal, Wales, Belgium, Germany, Croatia, Israel, Iraq, Uzbekistan, and the Altai Mountains of southern Siberia. That is an enormous world, and it is important to remember that this was never one continuous Neanderthal country. There were no borders, no capital, no central population sending people wherever they were needed. Their world was made up of local groups, families and bands living in particular landscapes, following particular herds, returning to known caves, stone sources, river crossings, and seasonal hunting grounds. A group in what is now northern Spain did not experience the world in the same way as a group in Crimea. A Neanderthal family sheltering in the mountains of the Caucasus faced different animals, different winters, different routes, and probably different neighbouring groups than people living beside the Rhone River in France. So, when their territory began to contract, it did not contract like a kingdom losing provinces. It contracted like a chain of campfires going out across a dark landscape. First one fire, then another, then a whole distant region where no one comes back. The archaeological record suggests that Neanderthal occupation became patchier over time, especially during the last part of their history. Sites that had once been used repeatedly were abandoned. Some regions show long gaps in occupation. Others show evidence of people returning after centuries, perhaps millennia, of absence. Still others seem to vanish from the record altogether. But we have to be careful here. An empty archaeological record does not always mean an empty landscape. Maybe people truly left. Maybe their numbers fell so low that they no longer visited the caves and rock shelters archaeologists have found. Maybe they camped in open-air sites that were later washed away, buried or destroyed by erosion. Maybe a group passed through once, leaving almost nothing behind. Stone tools survive well, human plans do not. Still, the broad pattern is hard to ignore. By the time we approach the final tens of thousands of years of Neanderthal existence, Their old range seems to have become less secure. Large areas that had supported Neanderthals in earlier periods no longer show the same clear evidence of continued occupation. The far north was especially difficult. During colder phases, much of northern Europe was simply not a reliable place for human populations. Ice sheets, permafrost, sparse vegetation, violent winds, and shifting animal herds made life there possible only in certain windows of time. Neanderthals had entered northern territories before, and they may have withdrawn from them more than once. This was not necessarily failure, it was mobility. When the land became too harsh, people moved south, followed the game, or waited for conditions to improve. But each retreat mattered, because returning to a region is easier when neighbouring populations are still nearby. It is easier when kin networks remain intact, when people remember roots, when there are enough groups to exchange mates, share materials, and pass along knowledge. It becomes much harder when the spaces between surviving groups grow wider. Imagine a map of Europe not as a solid block of Neanderthal territory, but as a scattering of islands. One island might be a sheltered valley in southern France, another, the foothills of northern Italy, another, the limestone country of the Balkans, another, a river corridor in the Near East. Between them are regions that may be cold, dry, forested, flooded, dangerous, or simply empty of familiar people. At first, the islands are close enough to remain connected. A hunting party travels, a family moves, stone from one region turns up far away, showing that people carried it or exchanged it. New partners arrive from another group. Stories, skills, and habits travel with them. But as the islands shrink, the crossings become harder. And that is one of the quiet dangers of contraction. A population can survive a bad climate event. It can survive a poor hunting season. It can even survive the loss of a familiar territory. What becomes dangerous is isolation. A small group cut off from others has fewer possible marriage partners, fewer allies in a crisis, less chance that someone from another valley will arrive with news of a better hunting ground, a useful stone source, or a route around a blocked mountain pass. If several children are born in one generation, the group may recover. If several adults die from injury, hunger, or illness, there may be no neighbouring band close enough to replace them. This is why extinction is rarely one dramatic event. It can be arithmetic. A few fewer people, a few fewer meetings, a few more empty valleys, and the timing would not have been the same everywhere. In Western Asia, Neanderthal populations had a long and complicated history. The Levant, the land between the Mediterranean and the deserts of Arabia, was especially important because it sat at a crossroads. During some periods it may have supported Neanderthals. During others, conditions changed, other human populations entered, or the available evidence becomes difficult to interpret. The region was not permanently Neanderthal or permanently anyone else's. It was a corridor, a meeting place, and sometimes a bottleneck. Further east, Neanderthal-related populations reached into Central Asia and southern Siberia. But these eastern groups may have been separated by enormous distances from those in Europe. Mountains, deserts, grasslands, and changing climates divided the land. A population could persist in one sheltered region, while another disappeared far away, without either group knowing much about the other. Europe itself was no simpler. In some parts of Central and Northern Europe, Neanderthal occupation seems to have repeatedly expanded and retreated with climate. When conditions opened up, people moved in. When cold or dryness intensified, they withdrew. Southern Europe often looked more promising, not because it was always warm, but because mountains, coasts, river valleys, and varied local environments created more options. This is where the idea of refugia becomes important. A refugium is a place where life can hold on while conditions worsen elsewhere. For plants, it might be a sheltered slope with enough moisture. For animals, a valley with reliable grazing. For humans, it could be a region with water, fuel, stone, game, caves and routes to neighbouring territories. Southern Iberia, parts of Italy, the Balkans and Western Asia may have served as refugia at different times. Not every one of them did so continuously. Not every cave in these regions was occupied until the end. But compared with exposed northern plains, these areas could offer a more complicated landscape, and complication can be useful. A coast offers shellfish, fish, seabirds, and protected coves. Mountains create different habitats within short distances. One slope may be dry while another holds trees. A river valley may provide water and animal movement even when surrounding country becomes difficult. A limestone cave may offer shelter, but more importantly, the landscape around it may offer choices. Choices are survival, yet refugia could also become traps. When populations retreat into the same favourable regions, they become concentrated in smaller spaces. Good territory is still limited. Herds do not become infinite because the climate is slightly better. Firewood still has to be gathered. Hunting grounds still have to be defended, shared, or avoided. And if a refuge is surrounded by difficult country, the people inside it may be safer in one sense, but more isolated in another. They are surviving, but they are surviving in pockets. By the time the final millennium of Neanderthal history begins to come into view, this is the landscape we need to picture. Not a whole continent filled evenly with Neanderthal communities. Not a sudden collapse. A scattered population, regional histories moving at different speeds. Some groups already gone from places their ancestors had known for thousands of years. Others still living in refuges, holding on to valleys, coasts, caves and uplands that remained workable. The Neanderthal world was becoming smaller, and soon those remaining islands of survival would face a new pressure from beyond their old boundaries. That new pressure was not a storm, or a glacier, or a drought. It was another kind of human. Homo sapiens had lived in Africa for hundreds of thousands of years. By the time Neanderthal populations were becoming scattered across Eurasia, our species had already developed its own long history of adaptation, movement and survival. And more than once, groups of Homo sapiens had moved beyond Africa into the lands of the Near East. Some of those early movements happened far earlier than the final Neanderthal disappearance. Fossils from the Levant suggest that Homo sapiens were present there at various times more than 100,000 years ago. Neanderthals were also present in the same broad region during other periods. The Levant was not simply a doorway that one species passed through and another species owned. It was a shifting borderland between Africa, Asia and Europe. Climate changed. Deserts opened and closed. Grasslands expanded and shrank. Human populations moved with the opportunities. So the first encounters between Neanderthals and Homo sapiens may not have happened in Europe at all. They may have begun in Western Asia in places where neither group was permanently dominant. A spring beside a migration route, a cave overlooking a valley, a river crossing used in different seasons by different communities. One group arriving after another had left, or perhaps, sometimes, both groups living within walking distance of each other. But the movement that mattered most for the final chapter of Neanderthal history came later, somewhere around 70,000 to 60,000 years ago, and perhaps in several movements rather than one single departure, Homo sapiens began expanding more successfully out of Africa. Groups moved through Arabia and the Near East. From there, their descendants spread east toward South Asia and Southeast Asia, north into Central Asia, and west into Europe. By roughly 45,000 years ago, Homo sapiens were appearing across parts of Europe. That sounds simple when compressed into one sentence. Homo sapiens arrive. Neanderthals disappear. But that is not what the evidence actually shows. Europe was huge, travel was slow, populations were small. Mountain ranges, rivers, forests, glaciers, and open steppe divided the landscape into separate worlds. A group entering southeastern Europe would not immediately affect people living in Iberia. A family settling in the Danube corridor might never meet a Neanderthal group in the mountains of Italy. News, if news travelled at all, would have moved through chains of contact, people meeting people, carrying fragments of knowledge farther than any one person could travel. The arrival unfolded across generations. In one valley, Neanderthals may have encountered newcomers quickly. In another, they may have continued living much as they always had for centuries or even millennia. Some regions may have seen only brief overlap. Others may have supported both populations for long periods. The dates are difficult because the archaeological record is incomplete, and because radiocarbon dating near its practical limits can be frustratingly uncertain. Still, the overall pattern is clear enough. By the beginning of the Upper Paleolithic, Europe was no longer a Neanderthal world alone. Archaeologists often recognize this change through stone tools and other surviving traces. Late Neanderthal sites are frequently associated with what is called the Mousterian tradition. This is a broad name for several related ways of making stone tools, often involving carefully prepared cores from which flakes could be struck in planned shapes. Neanderthals made scrapers, points, cutting tools, and other implements suited to a demanding life of hunting, butchering, hide working, woodworking, and survival in cold environments. The people arriving from the south and east brought tool traditions that are often grouped under names like the initial Upper Paleolithic and, later in much of Europe, the Aurignacian. These labels can sound like the names of armies, Mousterian people, Aurignacian people, as if each tool type belonged neatly to one biological species, moving across a map in straight lines. Real life was almost certainly messier. A stone tool tradition is not a tribe. It is not a language. It is not a face, a family, or a set of thoughts inside someone's mind. Technologies can spread between groups. People can copy useful methods. A community can change the tools it makes without being replaced by a new population. And different communities can make similar tools for completely different reasons. Even so, the new Upper Paleolithic assemblages often show a different emphasis. Long blades, carefully shaped bone and antler tools, ornaments, and more frequent use of symbolic objects become more visible in many Homo sapiens sites. Some of these technologies may have helped people make lighter, more efficient equipment. A long blade can be divided into several useful cutting edges. Bone points can be shaped in ways stone cannot easily match. Needles, though appearing later in the record, hint at the importance of fitted clothing in cold climates. But none of this means Homo sapiens arrived as superhumans and Neanderthals as helpless relics. Neanderthals had survived in Eurasia for hundreds of thousands of years. They knew their landscapes in ways newcomers could not. They understood where animals moved when snow deepened, where flint could be found, which caves held dry shelter, which valleys trapped cold air, and which routes remained passable in bad weather. They had sophisticated stone technology, controlled fire, cared for injured people, and hunted dangerous animals at close range. If Homo sapiens had advantages in some circumstances, those advantages were not magic. They may have included wider social networks, larger connected populations, or more frequent exchange of materials and information between distant groups. A small band facing a poor season is less vulnerable if it has allies in the next valley and allies beyond them. Newcomers may have carried ideas, mates, raw materials, and survival strategies across longer distances. They may have been better positioned to recover after local disaster because they belong to a wider network. But even that is an interpretation, not a simple fact carved into bone. Neanderthals also had social networks. They also moved materials. They also shared knowledge. The difference may have been one of scale, reliability, or population density, rather than a complete difference in human ability. And this is why the arrival of Homo sapiens changed the stakes. Before their arrival, Neanderthal groups faced a hard world, but mostly a familiar one. Climate shifted, herds moved, forests opened or closed. Neighbouring Neanderthal communities might compete, avoid one another, trade, exchange partners, or reunite after long separations. The dangers were serious, but they were part of an old pattern. Now another human species was entering the same patchwork of refuges. The best river valleys, the protected caves, the flint sources, the seasonal routes of reindeer, horse, bison, red deer, ibex and mammoth. None of these resources were unlimited, and during cold, unstable periods, the places capable of supporting people may have been especially rare. This did not require constant fighting. Competition can be quiet. If one group hunts a valley often, animals may become wary or move elsewhere. If one community occupies a rock shelter during winter, another has to find a different place. If a band uses the best stone source, others must travel farther. If a population grows slightly faster, maintains more connections, or recovers more easily after losses, it may gradually occupy spaces that another population once used. No battle, no conquest, just fewer options. For Neanderthals already living in scattered islands of survival, fewer options could be devastating. A large connected population can absorb losses. One group fails, another remains. A family can find new partners. People can move into an emptied territory. But a small, isolated population is more fragile. One severe winter, one failed hunt, one cluster of injuries, one generation with too few surviving children, and the balance begins to tip. The arrival of Homo sapiens did not create all of Neanderthal vulnerability. Climate instability, low population numbers, and fragmentation were already shaping their world. But another human population made recovery harder. It added pressure exactly where Neanderthals had the least room to spare, and eventually in caves, valleys, and open camps across Eurasia, the two kinds of human would come close enough to leave evidence not only in stone and bone, but inside the bodies of their descendants. What did those meetings look like? This is one of the most important questions in the entire story, and one of the hardest to answer. We know that Neanderthals and Homo sapiens occupied some of the same broad regions. We know that they overlapped in time. We know from DNA that they had children together. So at least some encounters were not distant sightings across a river valley. At least some involved trust, desire, coercion, alliance, adoption, or relationships we have no words for anymore. But archaeology almost never gives us the moment itself. It gives us stone tools in soil, burned bone in a hearth, a broken tooth, a shell carried far from the coast, layers of sediment that may represent occupations separated by days, years, centuries, or thousands of years. Archaeologists can sometimes show that Neanderthals used a cave and that Homo sapiens later used the same cave. But later is not the same as together. A site can preserve a long sequence of human visits and still tell us almost nothing about whether two groups ever stood there at the same time. Imagine a rock shelter beside a river. Neanderthals use it in autumn. They make a fire, butcher game, repair tools, then leave as winter closes in. 20 years later, a Homo sapiens hunting party shelters there for 2 nights. They find no Neanderthals. Perhaps they notice an old hearth stain in the dirt, a few flakes of worked flint, bones cracked open long ago for marrow. To them it may have looked like the trace of strangers. Or maybe it looked like nothing at all. Now imagine the same shelter, but with only 2 days between visits. The fire is still cold, but the ashes have not yet blown away. Footprints may remain outside if the ground is soft. A discarded tool lies near the wall. The smell of smoke and animal fat hangs in the air. The newcomers know immediately that other humans are nearby. The archaeological remains from both situations might look almost identical tens of thousands of years later. That is the problem. The record is not a movie. It is a collection of fragments, and the most dramatic moments are often the least likely to survive. A brief meeting in an open valley leaves very little behind. Two groups may see each other, speak, gesture, trade, fight, or retreat, and then walk away. Rain falls, grass grows, animals trample the ground. Within weeks, the landscape may erase nearly everything. So when archaeologists fail to find a clear encounter site, a place where Neanderthals and Homo sapiens can be shown beyond doubt to have met face to face, that does not mean they lived in complete isolation. It may mean that direct contact was brief. It may mean it happened outdoors. It may mean the evidence has not been found. Or it may mean that the two populations maintained distance most of the time, meeting only through scattered individuals moving between communities. And distance itself can take many forms. Perhaps some groups avoided each other. This would make sense in a world of small populations and uncertain resources. A band entering a valley might recognize signs that another group had recently hunted there. Freshly cut branches, tracks around a spring, a carcass stripped in a particular way, flint from a source beyond the horizon. They might decide not to investigate. There is no need to risk an encounter if food is scarce. Children are vulnerable, and nobody knows whether the strangers are friendly. Avoidance does not mean ignorance. Neanderthals may have known perfectly well that another kind of human was moving through the landscape. Homo sapiens may have heard stories of powerful hunters living beyond the next ridge. Information can travel surprisingly far through chains of contact. One group meets another. A person marries into a neighbouring community. A piece of unusual stone changes hands. A warning is passed along. Strangers are using the southern valley. Their tools are different. Their campfires are larger. They travel with more people than we do. We cannot recover those stories. But the people living then were not blind to the world beyond their own camp. In some places, contact may have been peaceful and practical. Exchange is possible. A useful raw material does not care which species carries it. Neither does a well-made tool, a piece of ochre, an animal hide, or knowledge about where herds are moving. If two groups met during a season of relative abundance, there may have been reasons to cooperate. They could share information. They could exchange objects. They could arrange partnerships. They could simply tolerate one another at the edge of a shared territory. There are hints, though not proof, that ideas moved between late Neanderthal and early Homo sapiens communities. In parts of Western Europe, some late Neanderthal-associated tool industries include objects that seem unusual in older Neanderthal contexts: personal ornaments, carefully worked bone tools, and new ways of shaping stone. The Châtelperronian tradition is the most famous example. Some researchers see it as evidence that Neanderthals adopted or adapted technologies and symbolic practices after encountering Homo sapiens. Others argue that the archaeological layers are mixed, or that the apparent connection is more complicated. The debate is still alive because the evidence is delicate, and a few disturbed centimetres of sediment can change the whole interpretation. But the larger possibility remains. People learn from other people. They watch, they copy, they improve, they borrow an idea and make it their own. A Neanderthal may have seen an unfamiliar blade and understood its usefulness. A Homo sapiens visitor may have learned a hunting route from people who had known that valley for generations. Cultural influence does not require peaceful friendship, and it does not require one side to be superior. It only requires contact, curiosity, and enough repeated proximity for a useful idea to cross the boundary. Of course, some meetings may have been hostile. That possibility should not be romanticized, but it should not be ignored either. Both Neanderthals and Homo sapiens were human enough to defend territory, fear strangers, compete over food, and respond violently when threatened. The best hunting grounds, sheltered caves, flint outcrops, and migration bottlenecks could matter enormously. During a bad season, even a small overlap in territory might become dangerous. Yet there is no evidence for a single great war between species. No battlefield where thousands died. No clear archaeological line showing a wave of Homo sapiens armies sweeping west while Neanderthals fell before them. That is probably the wrong scale for the question. These were not nations. They were small communities moving through immense landscapes. Conflict, if it happened, may have been local, a confrontation at a carcass, a dispute near a water source, an attack on a vulnerable camp. Or it may have been so rare that most people experienced the other species only as rumours, distant tracks, abandoned fires, and occasional strangers at the boundary of their world, and sometimes those strangers became part of the group. That is the fact waiting beneath all the uncertainty. The archaeology cannot tell us whether a particular Neanderthal woman met a particular Homo sapiens man beside a river in the Levant, or in a cave in Europe, or in a seasonal camp somewhere now buried beneath thousands of years of soil. But their descendants carry the evidence of such meetings in their cells. Not every encounter led to children, most probably did not. Some populations may have overlapped for generations without much interbreeding at all. Others may have mixed briefly, then separated again. The pattern was likely uneven, complicated, and deeply personal. Which is exactly what we should expect. Behind every stone tool tradition were individuals. People with families, fears, injuries, loyalties, and choices. People who could approach a stranger, turn away from one, imitate one, fight one, or build a life with one. The bones and tools can only bring us so close. To understand how close Neanderthals and Homo sapiens truly became, we have to look somewhere more intimate than a cave floor. We have to look inside ourselves. Inside ourselves, the evidence is still there. Not in the shape of a skull, or the thickness of a brow ridge, or a stone tool lifted from ancient soil. It is written in the long chemical code carried inside nearly every cell of your body. In 2010, scientists announced something that changed the Neanderthal story forever. By recovering and comparing DNA from Neanderthal bones, they found that living people of mostly non-African ancestry carry small amounts of Neanderthal genetic material. On average, it is often around 1 to 2% of the genome, though the exact amount varies from population to population and from person to person. That may not sound like much, 1 or 2%. A few scattered pages in an enormous library. But think about what it means. Neanderthals did not simply disappear without leaving a trace. They left descendants. Not descendants who still looked entirely Neanderthal, perhaps, and not a separate population living unchanged in some hidden valley, but descendants nonetheless. Their DNA entered Homo sapiens populations, travelled through thousands of generations, and survived all the way to the present. For much of the 20th century, the usual story was simpler. Neanderthals lived in Europe and Western Asia. Modern humans arrived. Neanderthals vanished. Homo sapiens replaced them. It was a clean narrative. One human species enters. Another leaves, but DNA made the story messier and much more human, because genes do not cross from one population into another by accident. At some point, Neanderthals and Homo sapiens had children together. Those children survived, at least some of them grew up, had children of their own, and became part of later communities. Their descendants had descendants. Generation after generation, the Neanderthal parts of their inheritance were carried onward. So when we say that many living people have Neanderthal DNA, we are not talking about a vague resemblance or a distant evolutionary connection shared by all apes and humans. We are talking about families, real people, living in particular places during particular seasons, forming relationships that resulted in children. The broad genetic picture suggests that one important period of mixing happened after Homo sapiens left Africa and encountered Neanderthals somewhere in Western Asia, perhaps around 50,000 to 60,000 years ago. But that is not the whole story. Ancient genomes have shown that interbreeding happened more than once. Different Homo sapiens groups encountered Neanderthals at different times. Some of those genetic lineages ended, some continued, and the encounters were not all equally ancient. One early Homo sapiens individual found in Romania, known from a skull fragment and jawbone in Pesteracu Oase, had a Neanderthal ancestor only a few generations back. Not hundreds of generations, not some distant figure lost in the mist of prehistory. Possibly as close as a great-great-grandparent or something in that range. Imagine that for a moment. A person living in Europe roughly 40,000 years ago had a Neanderthal relative close enough to be remembered in family stories. A grandparent, a great-grandparent, someone whose face, voice, habits, injuries, and place in the group might have been known. That does not tell us whether the relationship began in affection, alliance, pressure, captivity, or circumstances we cannot reconstruct. DNA is powerful, but it is not a witness. It cannot tell us whether two people chose each other freely. It cannot tell us what language they used, whether their families approved, or whether the child was welcomed. This is important. The fact of interbreeding is evidence of contact and reproduction. It is not evidence that every encounter was peaceful. It is not proof that Neanderthals and Homo sapiens lived together in harmony. And it is not permission to invent a neat story where every ancient boundary dissolved in friendship. Human relationships are rarely neat, even now. In the deep past, they may have included everything from long-term partnerships to brief encounters, negotiated exchanges, adoption into another group, coercion, violence, or relationships shaped by needs we no longer understand. The genome preserves the outcome. It does not preserve the feelings. Still, the outcome matters. It tells us that the boundary between Neanderthals and Homo sapiens was real, but not absolute. They were distinct populations with different histories, different bodies, and in many places, different ways of making tools and organizing life. But they were close enough biologically to have fertile children. Their lineages could join, their descendants could move through Homo sapiens communities and carry Neanderthal ancestry into the future. And that ancestry was not spread evenly across the genome. Over tens of thousands of years, natural selection seems to have removed many Neanderthal genetic variants from Homo sapiens populations. Some may have been poorly suited to the genetic background or environments of incoming Homo sapiens groups. Other regions of Neanderthal DNA remained, sometimes because they were neutral, sometimes perhaps because they were useful. A few surviving variants have been linked, cautiously, to things like immune responses, skin biology, metabolism, and adaptation to different environments. But this is a field where simple headlines can run ahead of the evidence. There is no single Neanderthal gene for strength, intelligence, red hair, depression, or any other complicated human trait. Most traits are shaped by many genes, by environment, and by lives that cannot be reduced to a percentage on a genetic test. The deeper lesson is quieter. Neanderthal DNA endured because Neanderthal people endured long enough to become ancestors. This changed the old extinction story. Instead of imagining a final moment where the last Neanderthal dies and an entire branch of humanity is cleanly cut away, we now have to consider another possibility. Some Neanderthal communities may indeed have died out without descendants. Small populations are vulnerable. A harsh winter, a failed hunt, an epidemic, an accident, or the loss of a few adults can be catastrophic when a group is already tiny. But other Neanderthals may have been absorbed. A Neanderthal person joins a Homo sapiens group. Their child grows up among Homo sapiens. That child has children with people who carry mostly Homo sapiens ancestry. A few generations pass. The visible boundaries become less clear. A family that once included a Neanderthal ancestor becomes part of a larger and growing population. The Neanderthal genetic contribution becomes diluted, but it does not vanish. It becomes part of everyone else. This does not mean Neanderthals were simply absorbed everywhere, or that interbreeding alone explains their disappearance. The amount of Neanderthal ancestry in living people is small, which means absorption cannot have been the only process at work. Separate Neanderthal populations still declined, fragmented, and eventually ceased to exist as a distinct people. But absorption may have been one thread in the larger ending. Not replacement alone, not extinction alone, a long, uneven transformation in which some communities disappeared, some individuals crossed into other communities, and some Neanderthal ancestors continued their journey inside Homo sapiens bodies. There is something almost strange about that. The people we call Neanderthals are gone as a separate population. Their caves fell silent. Their tool traditions ended. Their familiar faces vanished from the landscapes of Europe and Western Asia. But they are not entirely absent. They remain in fragments, scattered through living genomes. Not as ghosts, not as a lost race waiting to return, but as ancestors. And once we understand that, another question becomes impossible to ignore. If Neanderthals could have children with Homo sapiens, why did their separate populations become so vulnerable in the first place? To answer that, we have to leave the genome for a while and return to the world they lived in. A vast, cold, dangerous landscape inhabited by groups so small that every loss could matter. That vulnerability begins with a simple fact that is easy to overlook. Europe was enormous. The Neanderthal world stretched across mountains, river valleys, forests, open grasslands and cold plains from Western Europe into parts of Western and Central Asia. But a large territory does not necessarily mean a large population. In fact, the evidence suggests the opposite. For much of their later history, Neanderthals may have lived at remarkably low population densities, not cities, not even villages in the later farming sense. Small bands moving through large home ranges, following seasonal animals, returning to familiar shelters, gathering what the landscape could provide. A group might contain a few families, perhaps 20 people, perhaps 30, sometimes fewer, and the next group might not be just over the next hill. It could be days away, weeks away, separated by a mountain range, a dangerous river, an empty stretch of steppe, or a forest that offered little food in winter. This was not necessarily a failure. For hundreds of thousands of years, Neanderthals survived in these landscapes extremely well. Their bodies, tools, hunting practices, and knowledge of local environments allowed them to live where many other humans could not. But small numbers create a special kind of danger. Not the danger of being weak, the danger of having no margin for error. Imagine a band of 25 people at the end of a hard winter. Several are children, a few are older adults. Some are recovering from injury. Perhaps only 8 or 10 are active hunters and gatherers capable of making the long journeys, carrying meat, cutting wood, tending fires, and protecting the group. Now imagine that 3 of those adults die in a hunting accident, or a sickness moves through the camp, or a late freeze kills off the plants and animals the group expected in spring. In a large population, such losses are terrible, but they can sometimes be absorbed. Other families arrive, nearby groups provide marriage partners, knowledge survives in many hands. A community can recover because there are enough people left to rebuild. In a tiny, isolated band, the same event can change everything. One death may mean the loss of the only person who knows a distant flint source. Another may mean the loss of a skilled hunter, a healer, or an older relative who remembers where shelter can be found when the weather turns. The death of one woman of childbearing age, or one infant, can matter enormously over time. This is the cold mathematics of demography. A population does not need to be wiped out in one dramatic catastrophe to disappear. It can decline slowly, one bad year, then another. Too few births, too many deaths, a few young adults leaving to join another group and not being replaced. Eventually, there may simply be nobody left, and reproduction becomes difficult long before the final person dies. Small communities need partners from outside the immediate family. That means they need contact with other groups. They need journeys, meetings, alliances, exchanges, and some way of maintaining relationships over distances that could be dangerous to cross. If neighbouring bands also become small, scattered, or disappear, the problem grows worse. A group may have food for the moment, a warm shelter, and capable hunters. But if there are no suitable marriage partners nearby, its future narrows. Children may be born into a community with fewer and fewer unrelated adults. Close kinship becomes more common, genetic diversity declines. Harmful inherited variants, usually hidden in larger populations, can become more likely to meet and be expressed. This is not speculation based only on common sense. Ancient DNA has given us glimpses of this pattern. Several Neanderthal genomes show signs consistent with small effective population sizes over long periods. That phrase, effective population size, sounds technical, but the basic idea is simple. It does not count every living person exactly. It estimates how many individuals were regularly contributing their genes to future generations. For Neanderthals, those numbers appear to have been low compared with many later Homo sapiens populations. Their genomes also show relatively low genetic diversity. In some cases, researchers have found long stretches of similar DNA inherited from both parents, suggesting that the parents may have been related through fairly recent shared ancestors. Not necessarily siblings, and not proof that every Neanderthal group lived in the same way. But it is evidence that at least some communities were small, isolated, or both. One individual from the Altai region of Siberia, known from a toe bone recovered in Denisova Cave, had parents who appear to have been very closely related. That particular person lived far to the east of the last Neanderthals of Western Europe, and one individual cannot stand for an entire species. Still, the finding is revealing. It shows what can happen when human communities exist in small, separated pockets across a difficult landscape. The available circle of partners can become painfully narrow. Other genetic studies suggest that Neanderthal populations were not one united block, spread evenly across Eurasia. They were divided into regional communities. Some exchanged genes when they met. Some may have remained separated for long periods. Some local populations vanished and were later replaced by migrants from elsewhere. This is what biologists call a fragmented population. Think of small islands, except the islands are not surrounded by water. They are surrounded by distance, cold, empty country, unfamiliar terrain, and the constant work required to stay alive. A band in one valley may survive a harsh decade. Another band, only a few hundred miles away, may not. If travel between them is rare, the survivors cannot easily refill the empty space. The landscape remains, the caves remain, The hunting grounds remain, but the people are gone. And recovery is slow. That may be the most important part. Human populations grow one child at a time. Pregnancy takes time. Infants require care. Children take years before they can contribute fully to the daily work of the group. A community that loses 10 adults cannot replace them by the next season, even if food suddenly becomes abundant. It may take decades, so environmental shocks do not need to be permanent to have permanent effects. A few unusually cold years can reduce animal herds. A drought can alter river systems and plant growth. A volcanic eruption far away can darken skies and disrupt weather. A changing climate can move forests, grasslands, and prey animals across the map. None of these events has to destroy every Neanderthal group directly. They only have to push already small populations below the level from which they can easily recover. Then, before recovery is complete, another shock arrives. This is why the final Neanderthal millennia may have been so precarious. Not because Neanderthals suddenly forgot how to survive. Not because they were less intelligent, less brave, or less capable than Homo sapiens. The archaeological record does not support that kind of simple story. Neanderthals controlled fire. They made sophisticated stone tools. They hunted dangerous animals. They cared for injured people who sometimes survived for years. They adapted to changing conditions across an astonishing range of environments. Their problem may have been partly numerical. A highly skilled group of 15 people is still 15 people. They can know the land intimately. They can make excellent tools. They can cooperate with precision on a hunt, but they cannot create new adults when disease, hunger, injury, and time have taken too many away. And when those losses happened across many separated groups, the effects could compound. One band disappears from a river valley. Another no longer has anyone to trade with. A third has fewer possible partners for its young adults. Knowledge that once travelled along a chain of communities now has gaps in it. A stone source is forgotten. A seasonal route is no longer used. A familiar shelter is abandoned for the last time. This does not mean every Neanderthal community was isolated or doomed. Their long survival proves that they could maintain networks, share knowledge, and move across wide territories when conditions allowed. But the networks may have been thin, and thin networks can break, especially when the climate is changing, prey is shifting, and a new human population is beginning to appear in the same broad landscapes, because Homo sapiens did not enter an empty Europe. They entered a world where Neanderthals already knew every ridge, cave, river crossing, and hunting ground. But they may also have entered at a moment when many Neanderthal communities were living with very little room left for bad luck. And nowhere was that lack of room more dangerous than in the hunt. For Neanderthals, hunting was not a sport. It was not an occasional test of courage. It was the central calculation around which much of life was organized. Where are the animals now? When will they return? Which valley holds red deer in autumn? Which river crossing narrows the movement of bison? Which cliff edge, ravine, snowbank, or patch of deep mud can turn a powerful animal into a manageable one? A successful Neanderthal group did not simply wander through the landscape, hoping to find food. They carried detailed local knowledge, built over years and generations. They knew the habits of prey, they knew the seasons. They knew how weather changed animal movement. They knew which animals were too dangerous to approach alone, which could be ambushed, which could be driven, and which parts of a carcass had to be carried home before scavengers arrived. This knowledge was a kind of wealth, not wealth in coins or land deeds. Wealth in memory. A familiar hunting ground could feed a group through difficult months because its people understood it better than anyone else. They knew the sheltered places where animals gathered during storms. They knew the routes herds followed when snow covered the open ground. They knew where flint could be found for fresh cutting edges, where wood could be collected for spear shafts, and where a wounded hunter could be carried back to shelter. But that strength came with a problem. Local knowledge works best when the local world remains recognizable. And during the final Neanderthal millennia, for millennia, Europe often did not remain recognizable for long. Climate shifted repeatedly. Forests expanded, then retreated. Open grasslands appeared where woodland had stood. Cold steppes spread across regions that had once supported different plants and animals. Rivers changed course. Glaciers advanced and withdrew. Winters became harsher in some places, while other areas became wetter, drier, or more heavily forested. The animals moved with these changes. Reindeer herds could shift northward or eastward. Red deer might become more common as forests returned. Horse and bison populations could expand across open country, then become scarce when trees closed over the landscape. Woolly mammoths, rhinos, ibex, aurochs, wild boar, and smaller game all had their own ecological limits. For hunting people that mattered enormously, a route that had provided reliable prey for generations might suddenly lead to empty ground. Not permanently, perhaps, but long enough. And long enough can be fatal when a group has few stored reserves, few neighbouring communities, and several mouths to feed. The archaeological evidence shows that Neanderthals were often highly capable hunters. At many sites, animal bones carry cut marks made by stone tools, breaks made to reach nutritious marrow, and patterns suggesting that people had access to large portions of carcasses. In some places they seem to have focused heavily on particular prey. Red deer in one region, reindeer in another, ibex in mountain country, horse or bison on open plains. This was not necessarily narrow-mindedness. It may have been expertise. If a group knew one prey species intimately, it could hunt with greater efficiency. It could predict movement, understand behaviour, choose the best season, and reduce waste after a kill. A large animal could provide a remarkable amount of food, fat, hide, sinew, bone, and other useful material. But large animal hunting also carried risks. A deer can kick. A wild horse can crush a person. A bison can gore. An ibex can lead hunters into steep and dangerous ground. Even a successful hunt creates work that must be done quickly. Meat must be cut, carried, protected, and shared. In cold weather that may be easier to preserve. In warmer periods it can spoil rapidly, and before any of that happens, the animal has to be killed. Neanderthals used wooden spears, sometimes fitted with carefully shaped stone points. Evidence from their skeletons, injuries, and tools suggests that at least some hunting involved close-range encounters. That does not mean they rushed blindly at every animal. They may have used terrain, surprise, group coordination, traps of opportunity, and repeated attacks on weakened prey. But close hunting is never entirely safe. A single broken leg, a deep wound, or an injured shoulder could change a person's life. The bones of some Neanderthals show serious injuries that healed. This tells us something important. Their groups cared for people who could not immediately care for themselves. But it also reminds us how costly hunting could be. In a small band, an injured adult was not only a person in pain. They were also one less person able to travel far, gather fuel, carry meat, or help defend the group from hunger. Different Neanderthal populations probably managed these risks in different ways. In mountainous regions, hunting ibex or chamois may have been worth the danger because those animals were predictable and locally abundant. On open plains, horses or reindeer may have offered more reliable returns. In wooded country, hunters may have targeted deer, boar, and smaller animals, while relying more heavily on plants and other foods. There was no single Neanderthal economy. There were many local solutions to the same ancient problem. How do you feed a small group through another winter? And meat was not the whole answer. For a long time, popular images presented Neanderthals as almost entirely dependent on big game, powerful hunters living on mammoth steaks, day after day beside the fire. The reality was more complicated. Animal bones preserve well. Plant foods often do not. A roasted root, a handful of berries, mushrooms, nuts, seeds, or leafy greens can disappear from the archaeological record almost completely. But microscopic remains trapped in dental calculus. Traces of plant processing and evidence from some sites suggest that Neanderthals ate a range of plant foods when available. They likely gathered what their environments offered. Nuts in wooded regions, starchy underground plants, fruits and berries in season, seeds, possibly edible grasses, legumes, and other plants that required knowledge to identify and prepare safely. This matters because plant foods can provide calories when hunting fails. They can also provide variety, vitamins, carbohydrates, a different kind of security, but plant gathering has limits too. In an Ice Age winter, edible plants may be scarce. In cold open landscapes, the growing season can be painfully short. A bad frost, drought, or shift in rainfall can reduce plant foods just as surely as it affects animal herds. Coastal groups had other options. At a number of sites, evidence suggests that Neanderthals used marine and shoreline resources, shellfish, fish, seabirds, seals, and other coastal foods may have added to their diets where geography allowed. A shore can be a rich place if you know its tides, pools, seasonal movements and dangers. But coasts were not available to everyone, and the coastlines of the Ice Age were often far from today's shores, exposed when sea levels were lower. Many of those ancient landscapes are now underwater, along with much of the evidence of how people used them. Still, the broader point remains. Neanderthals were not simple specialists trapped in one rigid way of life. They could be flexible. They adjusted prey choice. They gathered plants. They used small animals and coastal resources in some regions. They responded to local conditions with the tools and knowledge available to them. So can subsistence pressure alone explain their decline? Probably not. Food stress was real. Changing climates could disrupt prey. Hunting injuries could be costly. A shrinking population could make every failed season more dangerous. But Neanderthals had survived environmental upheaval before. They had lived through cold periods, warm periods, expanding forests, open steppes, and shifting animal communities for hundreds of thousands of years. The final crisis was likely not one empty hunting ground, one missing herd, or one bad winter. It was the accumulation, less predictable food, smaller groups, fewer connections, more risk in every journey, and increasingly, another human population living in the same world, pursuing many of the same animals, moving through many of the same valleys, and looking for shelter when the weather turned. The hunt had always been difficult. Now it may have become a contest. And in a contest, the tools people carried could matter. Not because a sharper flake automatically wins history. Not because one species had technology and the other did not. Neanderthals had been making sophisticated stone tools for an immense span of time, far longer than Homo sapiens had been present in Europe. By the final millennia of their world, they were not holding crude rocks and waiting to be replaced by more advanced newcomers. They had systems. Across much of Europe and Western Asia, late Neanderthals used tool traditions archaeologists often group under the name Mousterian. The details varied from place to place because different landscapes required different solutions. But the underlying skill was clear. Neanderthal tool makers selected suitable stone, prepared it carefully, and removed flakes in planned sequences. One of their most famous methods is called Levallois technology. The name sounds technical because it is, but the basic idea is surprisingly elegant. Instead of striking a stone core at random and hoping a useful sharp edge comes off, the toolmaker shapes the core in advance. They create a controlled surface, prepare angles around it, and then strike in a way designed to release a flake of a particular size and form. That flake can become a knife, scraper, point, or cutting tool. It is not just breaking stone, it is planning several moves ahead. To do it reliably, a person needs to understand the properties of stone, the direction of force, the shape hidden inside the core, and the kind of tool required before the work even begins. A poorly placed blow can ruin the whole sequence. A skilled toolmaker can produce useful pieces again and again, often carrying a prepared core from one place to another, and making fresh edges when needed. This was a practical technology for a difficult life. A sharp flake could butcher a deer. It could cut tendons for binding. It could scrape fat and tissue from hides. It could shape wood into spear shafts. It could work bone, antler, and plant fibres, and when the edge became dull, it could sometimes be resharpened, altered, or replaced. Stone tools were only the parts that usually survive. The full Neanderthal toolkit was probably much larger. Wooden tools decay, rope decays, baskets hide containers, bedding, carrying slings, digging sticks, wooden wedges, and simple shelters almost always disappear. What remains in the ground is often the hard, durable skeleton of a much richer material world. Even so, archaeology gives us glimpses. At some sites, stone points appear to have been attached to wooden shafts. That process, called hafting, requires more than a sharp point and a stick. It may involve shaping wood, collecting binding materials, using sinew or plant fibre, and sometimes preparing sticky adhesives from resins, bitumen, or birch bark tar. Birch tar in particular is remarkable, making it can require controlled heating in low oxygen conditions, a process that suggests careful knowledge of materials and fire. Not every Neanderthal group used the same methods. Not every site preserves the evidence equally well. But the larger picture is hard to escape. They understood that separate materials could be combined into a more effective tool. A stone edge becomes more useful when it has a handle. A spear becomes more dangerous when its point is securely fixed. A hide becomes more valuable when it is cleaned, softened, cut, and shaped. And in Ice Age Europe, hides may have been among the most important resources a group could possess. Neanderthals lived through climates where exposed skin could become a serious problem very quickly. Cold, wind, rain, snow, and long winter nights did not merely cause discomfort. They increased energy demands. They made travel harder. They raised the danger of hypothermia, frost injury, and illness. A large body and powerful muscles helped generate heat, but biology alone was not enough. They needed culture to extend the body. Clothing is difficult to prove directly because leather, fur, and plant fibres rarely survive for tens of thousands of years. We do not have a Neanderthal coat hanging in a cave, waiting to be discovered. But we do have strong reasons to think they used animal skins, at least in some form. Hide-working tools are common. Scrapers often show wear consistent with processing hides. Their northern environments would have made some sort of covering, wrapping, bedding, or wind protection extremely useful. The exact form remains uncertain. A fur cloak draped over the shoulders is not the same thing as a tailored jacket with fitted sleeves. Simple wraps, capes, leggings, footwear, and more complex garments leave different traces, and the evidence does not always let us distinguish them. Some researchers have suggested that modern humans may have had more elaborate sewn clothing in certain regions, perhaps giving them an advantage in the harshest cold. Maybe, But it would be a mistake to imagine Neanderthals shivering helplessly in the snow, because they had not invented fashion. They survived repeated glacial cycles. They occupied cold regions for hundreds of thousands of years. Whatever their clothing looked like, it was part of a broader system of warmth and protection. Hides, fire, shelter, movement, food, and intimate knowledge of where to find cover. Fire sat at the centre of that system. A fire provides warmth, yes. But it also provides light, protection from some predators, a place to gather, and a way to transform food. Cooking can make meat easier to chew and digest. It can soften some plant foods. Smoke may help preserve food or discourage insects. Heat can dry wet clothing and hides. Coals can keep a camp alive through a cold night. But the evidence for Neanderthal fire use is more complicated than the old picture of every cave containing a permanent roaring hearth. Some sites preserve hearths, ash layers, burned bone, heated stone, and charcoal. Others do not. That absence may mean people did not use fire there. Or it may reflect poor preservation, brief occupations, later disturbance, or the simple fact that fire leaves fragile traces. In some regions and periods, Neanderthals seem to have used fire regularly. In others, the pattern is less clear. The safest conclusion is also the most interesting. Fire was not a magic possession, it was a skill that had to be maintained. A group needed fuel, dry wood, a protected place, knowledge of how to keep embers alive, how to restart a fire, and how to manage smoke in a shelter. During abrupt climate shifts, those needs could become harder to meet. Open steppe may offer less wood than forest. Wet conditions make fuel difficult. A moving group may have to choose between carrying embers, finding fresh fuel, or going without fire for a time. That is everyday adaptation, not one great invention. 1,000 small decisions. Where do we sleep tonight? Is this overhang dry enough? Can the wind reach the children? Is there fuel nearby? Can the hides be repaired before the next storm? Can we carry enough meat to the shelter before darkness? Neanderthals used caves and rock shelters when they were available, but they did not live only in caves. Open-air sites show that they also occupied river valleys, plains, hunting overlooks, and other exposed landscapes. They may have built windbreaks, used animal hides as coverings, arranged stones or branches, and returned repeatedly to places that offered water, fuel, stone, and protection. Most of those structures are gone now, but the logic remains visible in the places they chose. And then there is the question that has haunted this whole story. Did Neanderthals change their tools after Homo sapiens arrived because they learned from the newcomers? Sometimes, perhaps. In regions where the two populations overlapped, ideas could have moved between groups just as genes did. People can observe, they can imitate, they can trade. They can borrow a useful trick without becoming the same people. But parallel invention is also possible. Two human populations facing cold weather, difficult prey, and scarce raw materials may independently develop similar solutions. A new stone point does not come with a label explaining who invented it first. Archaeologists have to work from dates, distributions, manufacturing traces, and the uncertain record of sites that happen to survive. So we should be cautious. The presence of a new technique does not prove conquest. Similar tools do not prove copying, and technological complexity does not translate neatly into survival. Technology is not a scoreboard where the species with the most impressive equipment receives the planet. A tool only works within a whole social world. Someone has to know how to make it. Children have to learn. Raw material has to be found. Firewood has to be gathered. Hunters have to cooperate. Injured people have to be cared for. Knowledge has to survive when an elder dies, when a family moves, when a camp is abandoned, when a winter goes badly. This is where small populations become vulnerable. A group may possess excellent tools and still lose a skilled toolmaker. It may understand fire perfectly and still find itself in a treeless, storm-soaked landscape. It may know how to prepare hides and still lack enough animals after herds shift away. It may adapt brilliantly to one kind of cold, then face a sudden warming that transforms the forest, the prey, and the routes between familiar shelters. Neanderthals were not undone because they failed to adapt. Their long history proves that they could adapt. But adaptation has limits when change comes too fast. Populations are too small, and every useful skill depends on people being alive to pass it on. But tools are not the only things people make. Sometimes, in the deepest layers of a cave, archaeologists find objects with no obvious survival value at all. A shell carried far from the coast, a piece of red mineral ground into powder, an animal tooth with a hole bored through it, a claw that may have been worn, handled, or kept for reasons we can no longer recover. These are small discoveries, but they open very large questions, because a sharp stone tool tells us what a person needed to do. An ornament may tell us what they wanted to mean. Late Neanderthal sites in Europe contain increasing evidence for the use of pigments and decorative objects. Ochre, a naturally occurring mineral rich in iron, is one of the most common. It can be red, yellow, brown, or nearly black depending on its composition and how it is heated. It may have had practical uses. Mixed with fat, it can help preserve hides. It may repel insects. It can be used in adhesives. Powdered minerals might have been useful in processing materials or protecting skin. So pigment alone does not automatically mean art. A lump of red ochre is not a signed declaration of abstract thought. But at some sites, pigments appear to have been deliberately collected, transported, scraped, ground, and prepared. That suggests people considered them worth carrying, worth working, worth using again. And if a group is investing time in colour when life is already difficult, we should at least allow the possibility that colour mattered beyond simple utility. Shells raise the question even more sharply. At several sites associated with Neanderthals, researchers have found marine shells that appear to have been selected, modified, or stained with pigment. Some were brought inland from the coast. Some may have been perforated for suspension. In Spain, finds from caves such as Cueva de los Aviones have been interpreted as evidence that Neanderthals used shell ornaments and pigments long before modern humans arrived in Western Europe. That interpretation is important. It is also debated in its details. The dating of cave deposits is difficult. Layers can be disturbed. Water moves sediment. Animals burrow. Later, people enter the same shelter. A shell found near a Neanderthal layer is not always proof that a Neanderthal wore it. But the growing body of evidence makes the old simple picture increasingly hard to defend. The old picture was that Homo sapiens arrived in Europe carrying symbols, ornaments, art, and imagination, while Neanderthals watched from the sidelines. Reality was probably less tidy. Neanderthals may have used pigments. They may have collected unusual objects. They may have worn claws, teeth, shells, or feathers. At sites in Croatia, eagle talons with cut marks and polish have been interpreted as parts of a possible jewellery set. The objects are older than the arrival of Homo sapiens in that region, which makes them especially intriguing. Maybe they were ornaments, maybe they had another use we do not understand. Either way, somebody selected them, worked them, and treated them as more than food. And then there is the Châtelperronian. The name comes from the site of Châtelperron in central France. It refers to a late Ice Age archaeological tradition found mainly in France and northern Spain, dating roughly to the period when Neanderthals and Homo sapiens overlapped in Europe. Its stone tools include distinctive backed blades and curved points, often called Châtelperronian points. At first glance, this might sound like another technical category, another drawer in an archaeologist's cabinet. But the Châtelperronian sits directly inside one of the most important arguments about the final Neanderthals. Some sites linked to this tradition contain not only stone tools but bone tools, awls, pierced animal teeth, ivory pieces and ornaments. These objects look in some ways more like the material culture often associated with incoming Homo sapiens than with older Neanderthal traditions. So who made them? For decades, many archaeologists argued that the answer was Neanderthals. The strongest evidence came from sites such as the Grotte du Rennes at Arcy-sur-Cure in France. There, Châtelperronian layers were reported alongside Neanderthal remains and personal ornaments. If the association is secure, it means some Neanderthals were making or using decorative objects during the period of contact with Homo sapiens. That would not make them copies of modern humans. It would make them participants in a changing cultural world. But the site is complicated, very complicated. Caves are not sealed time capsules. Over tens of thousands of years, layers can shift. Objects can move downward through cracks. Later material can become mixed with earlier deposits. Critics have argued that some ornaments at Grotte du Rennes may have entered Neanderthal-associated layers from younger occupations above. Other researchers believe the association remains strong enough to take seriously. The debate is not settled because the evidence is not simple. And that uncertainty matters. There are several possible explanations. Neanderthals may have independently developed new forms of ornamentation and tool-making. They may have encountered Homo sapiens and borrowed ideas, materials, or styles. The two groups may have exchanged objects directly. Or the Châtelperronian may represent a more complicated mixture of populations, occupations, and cultural traditions than any single label can capture. None of these possibilities requires a dramatic story of one side teaching and the other side learning like children in a classroom. Cultural contact is usually messier than that. People observe each other. They exchange gifts. They imitate useful or attractive objects. They marry across group boundaries. They trade materials without sharing every belief attached to them. A bead can travel farther than the person who made it. An idea can cross a frontier even when the communities on either side remain strangers. And if you enjoy these ancient mysteries, the channel's book about the 12 unexplained mysteries is available through the website, with a link in the description. What makes this debate so important is not whether Neanderthals pass some imaginary test for being modern. They do not need our permission to have been human. The real question is what symbolic objects can reveal about social life. An ornament may signal identity, family, alliance, status, grief, memory. It may mark a person as belonging to one group rather than another. It may carry a story that is invisible to us now, but we have to stop where the evidence stops. A pierced tooth does not prove a religion. Red pigment does not prove cave painting. A collection of shells does not prove a fully developed language, a priesthood, or myths about the stars. Those things may be possible. They are not demonstrated. Still the objects remain: a little red powder, a shell from the sea, a tooth with a hole through it, small traces from the closing centuries of a human world, suggesting that Neanderthal life was not made only of cold, hunger, stone and survival. It may also have contained colour, display, memory and meaning. And if those meanings were shared, borrowed, or created anew during contact with Homo sapiens, then the final encounter between the two populations was not just a contest for land and food. It was also a meeting of minds, yes, but also, very possibly, a meeting of needs. Two human populations can exchange objects, share genes, observe each other, even borrow ideas from one another and still be competing. Competition does not have to mean constant fighting. It does not require armies, organized campaigns, or dramatic battles at the mouth of every cave. It can be quieter than that, more ordinary, more relentless. It means that two groups need some of the same things in the same places at the same time. A valley with a reliable spring, a sheltered cave before winter closes in, a migration route used by reindeer, horse or bison, a patch of woodland with fuel, edible plants and wood for spear shafts, a source of flint good enough to make sharp tools. In Ice Age Europe, these places were not evenly distributed across the landscape. Much of the continent could be harsh, exposed, seasonal and difficult to live in. A map may make Europe look enormous, but for small hunting populations, the truly useful parts of it may have been scattered like islands. And when Homo sapiens entered this world, they did not arrive in an empty continent. Neanderthals had lived across Europe and Western Asia for hundreds of thousands of years. They knew the rivers, the stone sources, the animal movements, the places where a cliff could trap a herd, and the caves that stayed dry when freezing rain swept across the plains. They were not helpless residents waiting to be replaced. But neither were they alone anymore. The newcomers needed many of the same things. They hunted large animals, they gathered plant foods when the season allowed. They needed warmth, safe sleeping places, raw materials, and people they could depend on. If their groups expanded into the same territories, even without open violence, the pressure on those shared resources could increase. Imagine two families arriving at the same small lake during a dry summer. There may be enough fish for both at first. Then the water level falls. Then one group catches a little more because it has more nets, more relatives nearby, or better information about where the fish are moving. Nobody needs to attack anybody, yet one family may gradually find itself with fewer options. That is what competition can look like. Not one final battle. 1,000 small advantages accumulating over generations. This is especially important because Neanderthal populations seem to have been small and scattered during their final millennia. Genetic evidence suggests that some groups were very small indeed, often isolated from one another for long periods. A local band might lose a few skilled hunters, a few mothers or a few children during one difficult winter, and the consequences could echo for decades. In a large population, losses can sometimes be absorbed. In a small one, they can change everything. Now add another population to the landscape. If Homo sapiens were arriving in somewhat larger numbers, or if they recovered from losses more quickly, that alone could have mattered. Not because they were necessarily stronger, smarter, or better in every situation, but because population size has a quiet kind of power. More people can mean more hunters when a large animal is brought down. More people can mean more possible marriage partners, reducing the risks of close kinship within a small community. More people can mean more individuals carrying different skills. Someone who knows a distant flint source. Someone who can repair clothing. Someone who remembers a route to a sheltered valley. Someone who has met another group and can call on them in a crisis. And more people can mean that knowledge survives when one group fails. If a Neanderthal band disappeared from a valley, their particular way of making tools, finding prey, or managing a seasonal camp may have disappeared with them. If Homo sapiens were connected to a wider web of communities, similar knowledge might have arrived again through visitors, marriage partners, or exchange. This is one of the leading ideas about why social networks may have mattered so much. Archaeologists have found evidence that some Upper Paleolithic Homo sapiens transported stone, shells, pigments, and other materials over considerable distances. Such finds are often interpreted as signs of broad exchange networks. People may have moved themselves, objects may have passed from hand to hand. The precise details are difficult to recover, but the basic possibility is powerful. A network can act like insurance. A group facing hunger can visit relatives elsewhere. A shortage of good stone can be eased by trade. A person can find a marriage partner outside their immediate community. News can travel, so can techniques, so can help. Neanderthals also moved materials across landscapes. They were not isolated cave dwellers with no connections beyond the next hill. Some raw materials at Neanderthal sites came from far away, showing planning, mobility, and perhaps exchange. But many researchers think Homo sapiens may have maintained wider or more frequent connections between groups. May have, that phrase matters. We cannot look into an Ice Age camp and count friendships. We cannot excavate a conversation, a marriage arrangement, or a promise of help made between families 2 valleys apart. Stone and bone preserve unevenly. Social ties preserve hardly at all. Still, the difference between a small local network and a larger regional one could be enormous when conditions turned bad. And conditions did turn bad. The final Neanderthals lived through rapid climate shifts, changing forests and grasslands, unstable animal populations, and repeated changes in the shape of the landscape itself. In such a world, competition may not have meant that Homo sapiens pushed Neanderthals from every territory by force. It may have meant that when a favoured hunting ground became less productive, Homo sapiens had more alternatives. More neighbouring groups, more routes, more places to go. For a small Neanderthal community with fewer connections, the same crisis could be much harder to survive. But competition cannot be the whole answer. If access to food and territory alone decided the outcome, we would expect a simple pattern. Homo sapiens arrive, Neanderthals vanish immediately. That is not what the evidence shows. In some regions, the 2 populations overlapped for thousands of years. They encountered one another. They may have exchanged ideas. They definitely interbred, at least sometimes. Neanderthals were not simply driven away like animals from a watering hole. Their decline was probably more complicated than any single explanation allows. Competition may have intensified the dangers already facing small populations. Climate instability may have fragmented habitats. Low numbers may have made recovery difficult. Disease may have played a role. Interbreeding may have absorbed some Neanderthal lineages into Homo sapiens populations rather than ending them outright. So perhaps the better question is not, did competition decide the outcome? Perhaps it is this. When the Neanderthal world was already becoming fragile, did competition make its fractures impossible to repair? The answer may be yes, not as a single violent event, but as pressure generation after generation on a people living close to the edge. And then there is the possibility of an enemy nobody could see. Not a rival hunting party, not a sudden freeze, not an empty valley where game had once been plentiful. A disease for years. Some researchers have wondered whether contact with Homo sapiens exposed Neanderthals to pathogens from which they had little protection. It is an unsettling idea, because it fits a pattern seen many times in more recent history. When populations separated for long periods meet again, they may carry different diseases and different immune defences. One group may have encountered a virus, bacterium, or parasite for generations. The disease is still dangerous, perhaps even deadly, but enough survivors have passed on immune traits that give their descendants some protection. Another group may have no such history. For them, the same infection can be devastating. This is sometimes called the disease hypothesis for Neanderthal decline. Homo sapiens moving out of Africa may have carried pathogens into Eurasia. Neanderthals, after hundreds of thousands of years living mostly in small scattered populations, may have had immune systems shaped by a very different set of infections. Contact between the groups could have opened a biological frontier as dangerous as any contested hunting ground. It is possible, but possible is not the same as proven. Disease is one of the hardest parts of prehistory to study because disease usually leaves almost nothing behind. A spear wound can mark a bone. A healed fracture can tell us about an injury suffered long ago. A hearth, a stone blade, or a buried body may survive for tens of thousands of years, but a fever does not fossilize. A cough leaves no tool. A virus can sweep through a camp in a few weeks and vanish without leaving a trace that archaeologists can easily find. Sometimes infectious disease does leave evidence in skeletons. Certain long-lasting illnesses can alter bone. Tuberculosis, leprosy, and some other infections may produce recognizable changes. But many of the diseases most capable of causing a rapid outbreak do not leave those kinds of marks. Influenza-like illnesses, respiratory infections, stomach diseases, and many viruses can kill without changing the skeleton in a clear diagnostic way. And ancient DNA from pathogens is extraordinarily difficult to recover, especially from remains this old. So when people say disease killed the Neanderthals, they are moving beyond the evidence. We do not have a Neanderthal graveyard containing clear proof of a pandemic. We do not have an identified Ice Age pathogen that appears with the arrival of Homo sapiens and then spreads neatly across Europe as Neanderthal populations disappear. We do not have a timeline showing one great epidemic moving from camp to camp, leaving empty caves behind it. That story would be dramatic. It would also be far more certain than the evidence allows. Still, the idea cannot simply be dismissed. The conditions for disease transmission did exist. Homo sapiens and Neanderthals met in some regions. We know that because they had children together. Their genomes prove contact more clearly than any artifact could. Modern people of non-African ancestry carry small amounts of Neanderthal DNA inherited from those ancient encounters. Some modern populations also carry Denisovan DNA, evidence of other meetings across Asia. Where people meet closely enough to form families, they are close enough to exchange microbes. And immune systems matter here. Neanderthals were not biologically defenseless. They had survived in Eurasia for hundreds of thousands of years. They must have faced parasites, infections, wounds, contaminated food, smoke-filled shelters, and the ordinary illnesses that come with living in small groups under difficult conditions. Their immune systems were adapted to their world. In fact, some Neanderthal genetic variants linked to immune function entered Homo sapiens populations through interbreeding and remain in people today. That suggests Neanderthals carried useful adaptations, perhaps shaped by long exposure to Eurasian pathogens. The exchange may not have gone in only one direction. Homo sapiens may have brought diseases unfamiliar to Neanderthals. Neanderthals may also have carried pathogens unfamiliar to Homo sapiens. And both groups may have gained useful immune variants from one another through their children. This makes the picture more complicated than a simple tale of newcomers bringing plague to an isolated people. There is another problem with the pandemic idea. Many of the most explosive infectious diseases thrive in large, dense populations. They need a steady supply of new hosts. A virus that burns through a small band of 20 or 30 people may then run out of people to infect. It can disappear almost as quickly as it arrived. The final Neanderthal populations were likely scattered across huge distances. That isolation may have made them vulnerable in some ways, but it could also have slowed the spread of a fast-moving epidemic, unless, of course, groups were connected often enough through movement, mating, seasonal gatherings, or exchange. And we do not know exactly how connected they were. A disease need not have killed every Neanderthal everywhere to matter. Even a local outbreak could be serious for a small community. Imagine a winter camp losing several adults who knew how to hunt, make tools, tend fires, or care for children. Imagine illness striking pregnant women, infants or older people who carried crucial knowledge. Imagine survivors weakened just as prey became scarce or weather turned severe. In a large population, recovery may be possible. In a small population already under pressure, a single bad season can become a turning point. That is where disease may fit best into the larger story, not necessarily as one giant catastrophe, not as a hidden plague that explains everything, but as one more strain on communities already dealing with climate shifts, shrinking habitats, uncertain food supplies, competition, and low numbers. The demographic evidence is stronger. Neanderthal populations appear to have been small, fragmented, and in some places isolated. The environmental evidence is stronger too. Their final millennia coincided with severe instability across Europe, changing landscapes and shifting animal communities. Archaeology and genetics both suggest that Homo sapiens were expanding through these same regions, often with wider social networks and perhaps greater capacity to recover from local losses. Those are facts with evidence behind them. Disease remains a hypothesis. A reasonable one, perhaps, an important one to keep in mind, but still an invisible possibility, not a solved case. And perhaps that is the most haunting part. The end of the Neanderthals may not have come from one visible blow. It may have come from many pressures arriving together. A colder season, a failed hunt, fewer neighbours, new rivals, an unfamiliar infection, and too few survivors left to begin again. But invisible danger was not the only danger in their world. Sometimes the past leaves its harshest evidence written directly on the body. Bones can tell us that someone was hurt. They can sometimes tell us where the injury landed, how severe it was, and whether the person survived long enough for healing to begin. What they usually cannot tell us is who caused it. That is the problem with violence in the Neanderthal story. A broken rib, a fractured skull, a damaged arm, a healed wound in the face. These are powerful pieces of evidence. They make the distant past feel suddenly intimate. Somewhere in an Ice Age valley, a person fell, was struck, crushed, kicked, gored, or caught in an accident. They suffered, in some cases they lived for years afterward. But the bone does not come with a witness statement. It does not say this was a fight. It does not say this was a hunt. It does not say this injury came from a Homo sapiens weapon. And that matters, because people have often looked at Neanderthal skeletons and imagined a final age of warfare. Neanderthals and modern humans meeting at the edge of a forest. Spears raised, rival bands fighting over caves, hunting grounds, and the last herds moving through a freezing landscape. It is a dramatic image, but drama is not evidence. Neanderthal remains do show trauma. Some individuals had fractures to the head, ribs, arms, hands and legs. A number of injuries healed, which tells us something important in itself. These people were not simply abandoned when they could no longer hunt or travel easily. Others must have helped them. Someone brought food. Someone tended fires. Someone protected them long enough for broken bones to knit back together. That is one message in the skeletons. Hardship, certainly, but also care. The famous Neanderthal remains from Shanidar Cave in Iraqi Kurdistan offer one striking example. One man, often called Shanidar I, lived with a remarkable collection of injuries and impairments. He had serious damage to his skull, likely limited vision in one eye, a withered arm that may have been partly unusable, and injuries affecting his legs and feet. Yet he survived into later adulthood. In an Ice Age hunting society, that survival was not automatic. It suggests sustained support from other people, not necessarily kindness in the modern sentimental sense. Cooperation is also practical. An experienced adult may know the landscape, remember seasonal movements of animals, make tools, teach children, prepare hides, or help organize a hunt even when badly injured. Still, survival after such damage tells us that Neanderthal communities could carry their vulnerable members through difficult years, and that should make us cautious about imagining them as endlessly violent brutes. Some skeletal injuries may indeed have come from interpersonal conflict. Humans, unfortunately, have always had the capacity to hurt one another. Small groups can quarrel. People can fight over food, mates, status, insult, revenge or fear. A close-range blow to the head is not impossible to interpret as violence, especially when the injury does not fit an obvious accident. But possible violence is not the same thing as proven warfare. A world filled with large animals, steep slopes, icy ground, stone tools, wooden spears, heavy loads, smoke-darkened shelters, and long-distance travel offered many ways to be injured without another person intending harm. Hunting itself was dangerous. Neanderthals often hunted large prey at close range. They faced bison, wild cattle, red deer, horses, and in some places mammoths, rhinoceroses, and other animals capable of killing a person in seconds. A frightened animal can kick, crush, gore, or throw a hunter. A spear can miss, a rocky ledge can collapse, a fall during winter can become a fracture, and a fracture can become a death sentence. Researchers have sometimes compared patterns of Neanderthal trauma with injuries seen in modern rodeo riders, because both involve the risk of close contact with powerful animals. The comparison is not perfect, and it should not be taken too literally. Ice Age hunting was not a rodeo, but it makes one useful point. A damaged skeleton does not automatically mean a battlefield. Even sharp injuries are difficult to interpret. A cut mark on bone may result from an attack. It may also come from butchery after death, burial disturbance, excavation damage, or processes that happened long after the person died. A puncture-like wound may look like it came from a weapon, but the exact shape of ancient trauma can be altered by decay, pressure, and time. Archaeologists have to be careful. They examine the location of the injury. Whether the bone began healing, whether there are marks from stone tools, whether the body was buried deliberately, whether multiple people at one site show similar wounds, whether weapons are present, whether there is evidence of repeated attacks across an entire region. For the final Neanderthal millennia, that larger pattern is missing. We do not have clear archaeological evidence for a continent-wide campaign by Homo sapiens against Neanderthals. We do not have battlefields full of Neanderthal dead killed by modern human weapons. We do not have fortified Neanderthal settlements under siege. We do not have a trail of massacres moving steadily westward as Homo sapiens expanded into Europe. That does not prove conflict never happened. It almost certainly happens somewhere. Two human populations using the same valleys, caves, rivers, and animal migrations would not always have ignored one another. A meeting could be tense. A hunting ground could be contested. A small clash over food or shelter may leave no trace at all, especially if only a few people were involved and their bodies were never preserved. But the evidence does not support a simple story in which modern humans arrived, fought one final war, and exterminated the Neanderthals. The real situation was probably far messier. In some places, the two groups may have kept their distance. They may have seen smoke from another camp across a valley and chosen not to approach. They may have used the same cave in different seasons, separated by years or generations. They may have avoided each other because avoidance was safer than conflict. In other places, they met closely enough to have children. That fact changes everything. Interbreeding does not mean every encounter was peaceful, equal, or welcome. Ancient DNA cannot tell us the emotions, circumstances, or power relationships behind each union. But it does tell us that absolute separation was not the rule. Neanderthals and Homo sapiens were not always enemies facing each other across an uncrossable boundary. They were people meeting people, sometimes strangers, sometimes rivals, sometimes neighbours, sometimes partners, and perhaps in moments we can no longer recover, members of the same extended family. Coexistence can mean many things. It can mean peaceful exchange. It can mean nervous tolerance. It can mean different groups occupying the same region while carefully staying apart. It can mean local hostility without endless war. It can mean one band disappears from a valley, while another arrives years later and never knows they were there. This is why the bones resist easy answers. They show that Neanderthal life could be brutal. Bodies were broken. Children and adults died young. Hunters faced risks that modern people can barely imagine. Small communities may sometimes have fought among themselves and perhaps with newcomers as well. But the bones also show endurance. They show healing. They show people surviving injuries that required help from others. The end of the Neanderthals was not likely a single violent event with one winner and one loser. It was a long narrowing of possibilities, played out differently from region to region. And in the far west of Europe, where the landscape broke into mountains, coasts, forests, and sheltered caves, a few Neanderthal communities may have held on longer than almost anyone else. So where did they go when the world was closing around them? If the last Neanderthal communities survived anywhere in Europe, many researchers have looked first toward the south and west. Iberia, southern France, Italy, the Balkans, not because these places were safe in any simple sense. Ice Age southern Europe could be bitter, dry, stormy, and unpredictable. Forests could shrink. Rivers could change course. Familiar animals could vanish from a hunting territory. A cave that had sheltered generations might become useless when the local landscape changed. But compared with the great northern plains, these southern regions often offered something precious. Variety, mountains, sheltered valleys, coastlines, rivers, wetlands, patches of woodland, open grassland, and rocky caves could exist surprisingly close together. When conditions worsened in one place, a small group might shift its hunting range rather than face an endless exposed journey across hundreds of miles of cold steppe. These were not paradise zones. They were refuges in the strictest sense of the word. Places where survival might remain possible when survival elsewhere had become much harder. During the coldest phases of the last ice age, enormous areas of northern and central Europe were transformed. Ice sheets pushed southward. Open steppe spread across regions that had once supported different ecosystems. Seasonal extremes became severe. Large herds still moved across the landscape, but following them required mobility, knowledge, and luck. A population already reduced to a few small bands could be pushed beyond its limits by one bad sequence of winters. In the south, geography sometimes softened the blow. The Iberian Peninsula, especially, has long seemed important. It is separated from much of Europe by the Pyrenees, a major mountain barrier. Its western coastline, southern shores, interior plateaus, river valleys and limestone caves created a complicated mosaic of environments. A group could live in one valley, hunt in another, gather plants along a river, and retreat to a sheltered rock overhang when weather turned dangerous. Southern France offered its own patchwork of river corridors, caves, wooded areas, and open country. It was also a crossroads, routes through the Rhône Valley, across the Pyrenees, and along the Atlantic and Mediterranean margins connected populations that may otherwise have remained isolated. Italy was more like a long mountain spine reaching into the Mediterranean. The Alps formed a formidable northern boundary, while the peninsula itself contained coastal zones, upland valleys, and sheltered regions that may have remained habitable through difficult climatic swings. Neanderthal sites appear across much of Italy, including places where marine resources, small game, plants, and large mammals may all have contributed to survival. And then there were the Balkans. Southeastern Europe was not simply a final corner of the map. It was one of the main gateways between Asia and Europe, a region of mountains, plains, river systems, coasts, and changing ecological zones. Neanderthals had lived there for a very long time. Later, Homo sapiens moved through many of the same broad corridors. That makes the Balkans important not only as a possible refuge, but as a contact zone. A place where populations may have overlapped, passed one another, exchanged genes, avoided one another, or competed for the same seasonal resources. But here is the difficulty. A refuge on a map is not necessarily a refuge in real life. When archaeologists say that Neanderthals survived late in Iberia, southern France, Italy, or the Balkans, they are usually talking about dates from particular sites. A layer in a cave, a hearth, a stone tool assemblage, animal bones with butcher marks, charcoal from an ancient fire. Sometimes a Neanderthal bone itself. Each one is a fragment. And fragments can be misleading. Imagine two caves, 50 miles apart. One has a Neanderthal-associated layer, dated to around 43,000 years ago. The other has one dated to around 39,000 years ago. At first glance, it is tempting to draw a line between them and say Neanderthals occupied the whole region continuously for 4,000 years. But perhaps they did not. The earlier cave may have been abandoned long before the later one was used. The groups may have been separated by generations. The sites may represent brief visits by tiny bands moving through a landscape that was otherwise empty. Or the dates themselves may have uncertainties large enough that the apparent sequence becomes less clear when examined closely. This is one of the central problems in reconstructing the end. Archaeological dates do not arrive with neat labels. Radiocarbon dating is incredibly powerful, but the final Neanderthal period sits close to its practical limits. Beyond roughly 40,000 to 50,000 years ago, tiny amounts of contamination can matter enormously. A trace of newer carbon entering an old sample can make it appear younger than it really is. Old charcoal can be moved by burrowing animals, water, erosion, or later human activity. Bones can absorb carbon from the soil around them. And even when a date is reliable, it may not date the event people think it dates. A piece of charcoal dates the burning of wood, not necessarily the making of the tools found nearby. An animal bone dates the death of that animal, not necessarily the last Neanderthal visit to the cave. A tool style may be associated with Neanderthals in one region and with Homo sapiens in another. The layers themselves can be disturbed, mixed, compressed, or separated by gaps too subtle to see during excavation. Then there is calibration. Radiocarbon years are not identical to calendar years. The amount of carbon in the atmosphere has changed over time, so raw dates must be adjusted using calibration curves. As methods improve, old chronologies can shift. A site once celebrated as evidence for an extremely late Neanderthal survival may turn out to be older than first believed. This has happened more than once. For many years, some Iberian sites were thought to show Neanderthals surviving until perhaps 30,000 years ago, long after Homo sapiens had spread through much of Europe. Those claims were exciting. They suggested that the far southwest of the continent had become a final Neanderthal homeland, a place where isolated communities endured for thousands of years after their relatives elsewhere had disappeared. Later redating and reanalysis made many of those very late claims much less secure. That does not mean Iberia was unimportant. It means the story is more cautious and probably more interesting. The evidence now tends to suggest that Neanderthals persisted in parts of Western and Southern Europe later than in many northern regions, but exactly how late, exactly where, and in what numbers remains debated. Instead of one final population holding an entire peninsula, there may have been scattered groups occupying favourable pockets of land. A valley here, a coastal district there, a network of caves used seasonally with long empty intervals between visits. Think again of the metapopulation idea. Not one large stable people spread evenly across a country. Small communities appearing and disappearing across a broken landscape. One group fails after a hard winter, another survives near a river corridor. A few families move into territory left empty by others. Connections become weaker, marriage networks shrink. Knowledge still passes between people, but less reliably than before. Eventually, the gaps grow too large. That may be what the last refuges really were. Not fortresses full of Neanderthals making a final stand against the future. More like islands of survival in an increasingly unfamiliar world. Small, mobile communities using the best remaining patches of habitat, perhaps unaware that other groups only a few valleys away had already vanished. And that is why there can be no single extinction date that satisfies every region. Neanderthals likely disappeared from some parts of Europe much earlier than others. In one valley, the final occupation may have ended before Homo sapiens arrived. In another, the two populations may have overlapped briefly. In another still, the archaeological record may simply be too thin to tell us whether there was overlap at all. Their ending was not one door slamming shut across an entire continent. It was a long fading a hearth gone cold in one cave, a hunting trail no longer followed in another, a stone tool tradition ending quietly, not with an announcement, but with the absence of the next generation. And at the southernmost edge of Iberia, facing the narrow waters between Europe and Africa, one place would become more famous than any other in this final chapter. Gibraltar. Gibraltar is a strange place to end a human world. A massive limestone rock rising above the sea. Europe on one side. Africa visible across the narrow strait on a clear day. Steep cliffs, sheltered coves, caves opening toward the Mediterranean, and a landscape that, during the Ice Age, looked very different from the crowded harbour and city that exist there now. Sea levels were lower then. The shoreline lay farther out. Broad coastal plains stretched below the rock. Freshwater sources, birds, shellfish, plants, ibex, red deer and marine resources may all have been available within a relatively small area. For a small population trying to survive in a difficult age, it may have been a good place to be. And among Gibraltar's caves, one name became almost legendary. Gorham's Cave. The cave lies on the eastern side of the rock, part of a larger complex that includes Vanguard Cave, Hyena Cave, and Bennett's Cave. Today, the entrance is close to the water, but when Neanderthals used it, the sea was often much farther away, and the cave looked out over a wide coastal landscape. Inside, archaeologists found deep layers of human activity. Stone tools made in the Mousterian tradition, the technology strongly associated with Neanderthals across much of Europe. Hearths, ash, charcoal, animal bones, evidence of repeated visits over a very long period. The remains suggest people were not merely passing through once on their way somewhere else. They returned. They made fires, they processed food, they shaped stone tools, they used the cave as one point in a familiar territory. That alone makes Gorham's Cave important. It gives us a rare glimpse of Neanderthal life at the far southwestern edge of Europe, in a place that may have remained habitable while colder regions farther north became increasingly difficult. But Gorham's Cave became famous for a more dramatic reason. For a time, some dates from its upper Neanderthal-associated layers appeared to suggest that Neanderthals may have survived there until around 28,000 years ago. That would have been extraordinary. By then, Homo sapiens had been present in Europe for many thousands of years. Most evidence suggested Neanderthals had disappeared much earlier, perhaps around 40,000 years ago, though the exact timing varied from region to region. A date near 28,000 years ago raised the possibility that Gibraltar had become the final refuge, the last corner of Europe where a few Neanderthal families endured, hunting beneath the rock while modern humans spread across the rest of the continent. It is an irresistible image, a tiny community, perhaps isolated for millennia. The last children born into a Neanderthal world, the last hunters making Mousterian tools beside a fire, the last people who carried an ancient European lineage that had survived ice ages, climate shifts, injuries, losses, and the arrival of another kind of human. The problem is that archaeology does not always cooperate with irresistible images. Those very late dates became heavily debated. Later work raised serious questions about whether the samples had been contaminated by younger carbon, whether the layers had been disturbed, and whether the dated material truly belonged to the final Neanderthal occupation, rather than to later activity above or within the sediments. New methods and revised analyses suggested that the Neanderthal levels at Gorham's Cave were probably older than the famous 28,000-year claim. Possibly much older, that does not make Gorham's Cave less remarkable. It simply changes the story. Instead of a securely dated final Neanderthal holdout surviving far beyond everyone else, Gibraltar may represent something more cautious. One of the latest important Neanderthal landscapes in Western Europe, certainly. A place where they persisted late into the broader period of decline, but not a place that can confidently be called the site of the last surviving Neanderthals on Earth. And that difference matters, because one revised date can transform an entire historical narrative. Imagine finding charcoal beside a Neanderthal stone tool and dating it to 28,000 years ago. It seems to place Neanderthals there at that moment. Then imagine learning that a tiny amount of modern carbon entered the sample through groundwater, roots, handling, or sediment movement. At this age range, that small contamination can shift the result by thousands of years. Suddenly, the final refuge becomes an earlier occupation. The last Neanderthals become not a known group in a known cave, but a possibility that has slipped back into the shadows. This is why the end of the Neanderthal record is so difficult to pin down. We are often dealing with the final thin traces left by small populations. A few tools, a fire, broken bones from a meal, sediment that has been exposed to tens of thousands of years of water, animals, changing temperatures and human disturbance. The record does not give us a final scene, it gives us fragments from which we try to build one. Gibraltar remains compelling because it shows what a refuge could look like, a sheltered coastal zone at the edge of the continent. Caves with long records of occupation, a varied landscape where people could draw on several kinds of food and move between different habitats without travelling enormous distances. But it also shows the limits of what we can know. Perhaps Neanderthals remained there late, in scattered bands, while Homo sapiens moved through other parts of Iberia. Perhaps the caves were abandoned earlier than the legend suggests. Perhaps the very last Neanderthal community lived somewhere else entirely, in another valley, another coast, another cave whose evidence has not survived or has not yet been found. The last Neanderthals may never have known they were the last. There was no final gathering beneath the rock. No one carved the date into a wall. No one left a message saying that their people had reached the end. There were only lives continuing for as long as they could. And then, eventually, no more Neanderthal hearths appear in the record. But how do we put a date on an ending that no one recorded? The answer begins with one of archaeology's most useful tools, and one of its most misunderstood. Radiocarbon dating. Every living thing takes in carbon. Plants absorb it from the atmosphere. Animals eat the plants or eat animals that ate the plants. As long as an organism is alive, the balance of carbon in its body is constantly renewed. Then it dies. At that point, one particular form of carbon, carbon-14, begins to decay at a known rate, slowly, steadily, atom by atom, disappearing over time. By measuring how much carbon-14 remains in a piece of charcoal, a bone, a shell, or another once-living material, scientists can estimate how long ago that organism died. It sounds almost magical. Find a hearth made by Neanderthals. Date the charcoal. Find an animal bone cut with Neanderthal tools. Date the bone. Build enough dates from enough sites, and perhaps the final horizon of Neanderthal life begins to come into focus. But there is a problem. Radiocarbon dating is strongest when dealing with material from the recent past. A few thousand years, 10,000 years, even 20,000 years, if the sample is good. The Neanderthal disappearance sits near the practical edge of the method. Most estimates place their final disappearance in Europe somewhere around 40,000 years ago, give or take several thousand years depending on the region, the site, and the method used. And around 40,000 years ago, there is very little carbon-14 left. Not none, but very little. Carbon-14 has a half-life of about 5,730 years. After one half-life, half of it remains. After another, half of the remainder. Then half again. By the time 40,000 or 45,000 years have passed, the original signal has become incredibly faint. Dating a sample from this period is a little like trying to hear a whisper at the far end of a crowded room. The whisper may still be there, but almost anything can interfere with it. This is where contamination becomes so important. Imagine a piece of Neanderthal bone that is truly 45,000 years old. Over tens of thousands of years, water moves through the sediment around it. Roots grow nearby. Microbes enter tiny cracks. Minerals seep into the bone. Then, much later, archaeologists excavate it, conserve it, handle it, and prepare it for analysis. If even a small amount of younger carbon enters that ancient sample, it can make the bone appear much more recent than it really is. And because there is so little original carbon-14 left at these ages, a tiny contaminant can have a large effect. A sample that is actually 45,000 years old might seem to be 40,000 years old, or younger enough to change the apparent overlap between Neanderthals and Homo sapiens. Enough to create a dramatic late survival claim. Enough to turn one cave into the supposed last refuge of an entire human species. Older contamination can cause problems too, though younger carbon is usually the major concern when researchers are trying to establish a late date. This is why archaeologists do not simply date anything found in a Neanderthal layer and accept the number that comes back. They ask difficult questions. What exactly is being dated? Charcoal may date a fire, but was that fire made by Neanderthals? Could charcoal have moved downward from a younger layer? Could people have burned wood that was already centuries old, perhaps from the heartwood of a long-lived tree or driftwood gathered from an ancient deposit? Animal bone may sit beside stone tools, but did humans leave it there? Was it gnawed into the cave by carnivores? Did sediment shift after the original occupation? Is there enough surviving collagen, the protein within bone, to produce a reliable date? The best samples are often those with a direct and clear relationship to human activity. Burned bone from a securely identified hearth. A bone with cut marks, if enough collagen remains. Charcoal from an undisturbed fire feature. Even then, caution remains necessary. Scientists also use increasingly rigorous cleaning methods. For bones, laboratories try to isolate and purify collagen, removing substances that may have entered long after death. Some methods filter the collagen further, selecting the larger, more stable molecules most likely to preserve an authentic ancient signal. For charcoal, chemical treatments remove humic acids and other contaminants carried through soil and groundwater. These procedures have transformed the study of the last Neanderthals. Many famous early dates were produced when techniques were less able to detect or remove contamination. As laboratories improved, some apparently late Neanderthal dates became older. Not because the past changed, obviously, but because the measurements became more reliable. And then there is calibration. Radiocarbon years are not identical to calendar years. The amount of carbon-14 in Earth's atmosphere has varied through time, influenced by changes in solar activity, Earth's magnetic field, ocean circulation, and the carbon cycle itself. So a radiocarbon measurement has to be matched against calibration curves built from independent records, including tree rings, cave deposits, corals, and other materials. Near 40,000 years ago, those calibration curves become less smooth and more uncertain. A single radiocarbon measurement may correspond to a range of possible calendar ages. Sometimes the curve contains wiggles and plateaus, periods where similar radiocarbon values can map onto quite different real dates. So when someone says a Neanderthal site is 41,000 years old, the more honest version is often something like this. The available evidence suggests it falls within a range centered roughly around that time, with uncertainty that may be substantial. Not as satisfying, perhaps, but much closer to the truth. To handle this uncertainty, researchers increasingly use statistical modeling. Instead of treating every date as an isolated number, they combine dates with archaeological information. They consider the order of layers in a cave. They account for which occupation came before another. They compare dates across regions. They exclude samples judged unreliable. They test different scenarios. This approach, often called Bayesian modeling, does not magically reveal the exact year the final Neanderthal died. What it does is estimate the most likely window in which Neanderthal occupations ended at a particular site, or across a wider region. That distinction is crucial. The last known Neanderthal evidence is not the same thing as the last Neanderthal individual. If the youngest securely dated Neanderthal hearth in a region is around 41,000 years old, that tells us Neanderthals were still there, at least until that time. It does not tell us they vanished the next morning. A small group may have survived for generations, centuries, or longer without leaving evidence that archaeologists have found. Small populations are especially easy to lose from the record. A family might occupy a rock shelter briefly, leave only a few tools, and have those tools buried where no one will ever excavate. They might live in an open-air camp later destroyed by erosion. Their final descendants may have used perishable tools of wood, hide, and fibre that vanished completely. Archaeology records preservation, not every life that was lived. So the final Neanderthal date will probably never be one clean number. It will remain a narrowing window, a fading edge of hearths, bones, tools, and genetic traces. A period when Neanderthal communities became rarer across Europe, while Homo sapiens populations expanded, climates shifted, and old territories were abandoned. The question is not simply when did they disappear? It is also what do we mean by disappeared? What do we mean by disappeared? It sounds like a simple question. A species exists. Then it does not. Extinction. But with Neanderthals, the ending is not quite that clean. If we mean biological extinction in the strictest sense, then yes. Neanderthals no longer exist as a distinct population. There are no communities living today whose members carry only Neanderthal ancestry, speak a Neanderthal language, follow Neanderthal traditions, or reproduce mainly within a separate Neanderthal society. The distinctive lineage, shaped over hundreds of thousands of years in Europe and Western Asia, is gone. Their heavy brow ridges, their broad rib cages, their powerful bodies adapted to cold landscapes, their particular ways of making tools, organizing camps, hunting animals, caring for the injured, and perhaps marking death with ritual. That living world ended. But biological extinction does not always mean every gene disappeared. And this is where the story becomes more complicated. When Homo sapiens expanded into Eurasia, they did not simply pass Neanderthals at a distance and replace them without contact. At least sometimes the two populations met closely enough to have children together. We know this because the evidence is still inside us. Most living people with ancestry outside sub-Saharan Africa carry roughly 1 to 2% Neanderthal DNA, though the exact amount varies between populations and individuals. Some African populations also carry small amounts, probably through later movements and mixing among modern human groups. This does not mean that any person alive today is partly Neanderthal in a simple personal sense, as if one recent ancestor stood in a family tree. The mixing happened tens of thousands of years ago. Generation after generation, the inherited fragments were broken apart and reshuffled. What remains are scattered pieces, a gene here, a short stretch of DNA there. Tiny surviving pages from a much older human history. Still, those pages matter. They tell us that at least some Neanderthals did not vanish without descendants. Some had children with Homo sapiens. Those children had children. And eventually their descendants became part of populations that identified socially and culturally as Homo sapiens. This is sometimes called absorption or assimilation. It is one possible part of the Neanderthal story, not necessarily the whole story, but a real part. Imagine a small Neanderthal group living near a larger and more connected Homo sapiens population. Perhaps the groups met at a river crossing, a seasonal hunting ground, or the entrance to a sheltered valley. They may have exchanged materials, they may have watched one another from a distance for years before any closer contact happened. Then, slowly, individuals moved between communities. A Neanderthal woman might have joined a Homo sapiens group, or a Homo sapiens man might have joined a Neanderthal camp. Their children would have belonged to a world already changing around them. If they grew up speaking the language, learning the skills and following the social rules of the larger community, then their Neanderthal ancestry could continue even while Neanderthal identity faded. Within a few generations, the genetic inheritance would remain. But the separate peoplehood would not. This happens in human history more often than we might think. Languages disappear while descendants remain. Customs are abandoned. Small communities marry into larger ones. A population can survive in bodies and family lines, while its name, traditions, and sense of itself dissolve into another society. So perhaps the final Neanderthals did not all die in isolated caves, facing a harsh winter alone. Some probably did die without descendants. Small populations are vulnerable. A few bad hunting seasons, a disease outbreak, an injury, a difficult birth, or the loss of several adults could push a tiny band past the point of recovery. But some may have been drawn into expanding Homo sapiens networks. Not conquered in one dramatic event, not necessarily welcomed warmly either. Human contact can involve cooperation, curiosity, exchange, fear, violence, marriage, and unequal power, sometimes all at once. The archaeological record cannot tell us the emotional texture of every meeting. It cannot tell us whether these unions were chosen, negotiated, forced, or shaped by circumstances we can no longer see. What it can tell us is that mixing happened, and it happened more than once. The genetic record suggests that Homo sapiens and Neanderthals interbred during different periods and in different places. There may even have been earlier episodes of contact long before the final disappearance in Europe. Their histories were not two separate lines moving toward one final collision. They overlapped, separated, and overlapped again. Yet interbreeding alone cannot explain everything. If a few Neanderthals entered Homo sapiens communities each generation, their genes could persist. But if Neanderthal communities remained numerous and stable, they would also continue as a distinct population. For absorption to become important, the balance had to change. And by the last millennia, it seems to have changed dramatically. Climate instability broke familiar landscapes into shifting patches of forest, grassland, ice, and open steppe. Neanderthal groups were already scattered thinly across enormous territories. Homo sapiens populations arriving from the south may have had wider social networks, greater numbers in some regions, or more flexible ways of moving resources and information across long distances. None of these advantages had to be absolute. A slightly larger population can matter. A slightly broader network can matter. A few more potential marriage partners can matter. In a world where groups may have contained only dozens of people, small differences accumulate. Over generations, Neanderthal communities may have become fewer, more isolated, and more likely to merge with neighbouring Homo sapiens groups. So was it extinction? Yes, if we mean the end of Neanderthals as a distinct human population. Was it absorption? Also, yes, at least in part. Their DNA did not vanish. Some of their descendants became part of us. Was it transformation? Perhaps that is the quietest and strangest answer of all. The Neanderthal world did not simply go dark. Pieces of it continued, carried forward in the bodies of people who no longer called themselves Neanderthals, if they ever used a name for themselves at all. Their identity disappeared. Their lineage did not disappear completely. And between those two truths lies the real ending. Not one final moment, but a long and uneven process of loss, contact, survival and change. And that is why the Neanderthals leave behind more than bones. They leave behind a question, not just what happened to them, but what does it mean for a human people to be gone? For more than a century, Neanderthals were treated as a warning from the past. Their skeletons were reconstructed with bent knees, lowered heads, and expressions of permanent confusion. They were imagined as brutish cave dwellers, barely capable of speech, too slow or too simple to survive when smarter humans arrived. That picture was powerful, and it was mostly wrong. Part of the problem was that the first famous Neanderthal skeleton discovered was old, injured, and badly preserved. Scientists looked at a person who had lived a hard life, probably with arthritis and other physical problems, and turned him into the model for an entire species. They saw his curved spine and heavy bones, then imagined a creature halfway between ape and human. But Neanderthals were never halfway anything. They were human relatives, a sister lineage. Different from us, certainly, but not unfinished versions of us, not failed Homo sapiens waiting to be replaced. They had been living in Europe and Western Asia for hundreds of thousands of years before modern humans arrived. They survived repeated glacial cycles, enormous climate shifts, changing animal migrations and landscapes that could transform within the span of a few generations. They knew their world. Their archaeological traces are often quiet. A scatter of stone flakes beside a hearth, animal bones broken for marrow, a carefully shaped tool dropped in the mud of a riverbank, a sheltered cave used again and again over centuries. These remains do not give us names, stories, or voices, but they show skill, planning, and persistence. Neanderthals chose particular stone sources, sometimes carrying good raw material across long distances. They made tools for cutting meat, scraping hides, shaping wood, and working bone. They controlled fire. They prepared food. They hunted large animals, but they also used plants, small game, birds, shellfish, and whatever local environments could provide. In some places they used pigments. In others they collected eagle talons, unusual shells, or striking mineral objects. These things may have been ornaments, symbols, or simply objects valued for their rarity. The evidence does not let us read their thoughts with certainty. But it does not allow us to dismiss those thoughts either. The old story said that symbolism belonged only to Homo sapiens. Then evidence became more complicated. Cave markings in Spain may date to a time before modern humans reached the region, though dating cave art is difficult and interpretations remain debated. Pigment use appears at Neanderthal sites. Personal ornaments appear in the final millennia of their history, sometimes in settings where contact with Homo sapiens was possible. Did Neanderthals independently create symbols? Did they borrow ideas from neighbouring Homo sapiens groups? Did both populations share knowledge in borderlands where people met, traded, copied, and occasionally joined one another's communities? The honest answer is that we do not always know, but uncertainty is not emptiness. It is a reminder that the past was more complicated than the old categories allowed. Then genetics changed the story even more. For a long time, Neanderthals could only be studied through their bones and tools. Researchers could measure skulls, compare teeth, and argue over the shape of a stone point. But ancient DNA opened a door that had seemed permanently closed. Fragments of Neanderthal genetic material, extracted from remarkably preserved bones, showed that they were close relatives of living humans. Not our direct ancestors in the simple sense, more like cousins descended from an older shared population. And then came the larger surprise. Their DNA survives in many of us. Not as a complete Neanderthal inheritance, and not in equal amounts everywhere, but as small fragments passed through countless generations. Some of those fragments are associated with immune responses, skin biology, hair traits, and adaptation to environments outside Africa. Others may have had little effect at all. Some Neanderthal DNA appears to have been removed over time by natural selection, especially in parts of the genome where it did not work well with Homo sapiens' genetic backgrounds. So the legacy is not simple. It is not a hidden Neanderthal personality sleeping inside modern people. It is not proof that one population was better or worse than another. It is evidence of ancient contact, ancient families, and ancient children born between groups we once imagined as completely separate. That changes the meaning of the word human for much of prehistory. There was not only one kind of human walking the earth. There were several: Homo sapiens, Neanderthals, Denisovans, and probably other populations we have not yet identified clearly from the fragmentary record. They were not all the same. Their bodies differed. Their histories differed. Their adaptations differed. Their cultures may have differed in ways we can only partly recover. But the boundaries were not absolute. They could meet. They could exchange genes. They may have exchanged tools, materials, habits, and knowledge. Their lives overlapped in the same valleys, the same caves, the same hunting grounds, under the same cold skies. That should make us pause. Modern humans often like clean categories. Us and them, ancestor and stranger, success and failure. But Neanderthals make those categories uncomfortable. They were different enough to be recognizable, close enough to interbreed, skilled enough to survive for an immense stretch of time, and vulnerable enough to disappear as a separate people. Their story is not about stupidity losing to intelligence. It is about survival in small populations. It is about how much a group can endure when climate changes, numbers fall, neighbours arrive, and familiar social networks begin to break apart. It is about the cruel mathematics of isolation. A people can be capable, knowledgeable, and deeply adapted to its environment, yet still be overwhelmed by circumstances no individual can control. And it is about identity. A Neanderthal child raised within a Homo sapiens community may have carried Neanderthal ancestry while growing up in a different cultural world. Over time, the old identity could fade, even as the descendants continued. Genes remained. A distinct people did not. That is not a simple ending. It is a human ending. The Neanderthals leave behind tools in the soil, hearths darkened by old fires, bones marked by labour and injury, traces of pigment, fragments of DNA, and a challenge to every easy story we tell about progress. They remind us that evolution does not move in a straight line toward us. We are not the destination that all earlier humans were trying to reach. We are simply the human population that remained, expanded, mixed, changed, and survived into the present. And if we want to know what really happened to the Neanderthals, we have to hold all of that together. They were lost, they were absorbed, they were replaced in some places. They left descendants, they left questions, and the final answer is not a single dramatic event, but a slow closing of possibilities across thousands of years. And that slow closing is the closest thing we have to an answer. The final 10,000 years of the Neanderthal world were not necessarily a single disaster. There is no confirmed day when the last group looked out from a cave mouth, saw a new people on the horizon, and vanished before nightfall. No final battlefield, no one great epidemic we can point to, no single volcanic winter, flood, or famine that explains everything. Instead, the evidence suggests an unravelling, slow in some regions, faster in others. In parts of Europe, Neanderthal populations may have disappeared before Homo sapiens had spread very far. In other places, the two populations overlapped for thousands of years. They occupied neighbouring territories, perhaps sometimes the same valleys at different seasons. They hunted similar animals. They collected the same useful stone. They sheltered in some of the same caves, and occasionally they had children together. That is important, because it means the end of the Neanderthals was not only a story of disappearance, it was also, in part, a story of merging. But merging did not make the pressures disappear. The climate in this period was unstable in ways that mattered deeply to small hunter-gatherer groups. Ice sheets advanced and retreated. Forests opened into grassland, then shifted again. Herds moved. Familiar hunting routes became unreliable. A valley that supported a small community for generations could become colder, drier, or more heavily wooded within a human lifetime. For a large population spread across wide networks, this would have been difficult. For small, scattered Neanderthal communities, it may have been devastating. Imagine a group of perhaps a few dozen people. A successful hunting season is followed by a bad one. An older hunter dies. A skilled toolmaker is injured. Several children do not survive the winter. Another band, once connected through marriage or seasonal meetings, is no longer there when spring comes. Nothing about this requires anyone to be less intelligent, less brave, or less adapted. It is simply the brutal arithmetic of small populations. When numbers fall too low, every loss matters more. Knowledge can disappear with a single person. Finding marriage partners becomes harder. Close relatives may have to form families. A group can become isolated not because it chose isolation, but because the next group over has quietly vanished. Then add Homo sapiens to that already difficult equation. Modern humans may have brought wider social networks, allowing materials, information, and marriage partners to move across greater distances. They may have recovered more quickly after local shortages. They may have competed for prey, territory, and shelter. In some areas, even a small advantage in numbers or connections could have mattered over many generations. But competition does not have to mean constant violence. Sometimes competition is quiet. Two groups use the same landscape. One slowly becomes more numerous. One can replace losses more easily. One has distant allies to call upon when a local resource fails. Over centuries, the balance changes. The smaller network becomes thinner, more fragile, and finally breaks. Disease may have played some role as well. Populations separated for long periods can carry different pathogens and different immune histories. But this remains difficult to prove. Ancient diseases rarely leave clear signatures in the archaeological record. It is possible, it is not certain, and that uncertainty is worth keeping, because the archaeological record does not preserve the final moments of every people. It preserves fragments, a hearth here a tooth there, stone tools buried beneath wind-blown dust, a cave layer disturbed by animals, water, later visitors, and tens of thousands of years. The last Neanderthal site we have found is not necessarily the place where the last Neanderthal person lived. The last date we have measured is not necessarily the last date of their existence. There may have been small groups holding on in overlooked valleys, coastal refuges, or landscapes where organic traces simply did not survive. There may have been communities that gradually joined Homo sapiens groups until no separate Neanderthal population remained to identify. So what really happened to the Neanderthals? Probably not one thing. Climate instability narrowed their options. Small populations made them vulnerable. Contact with Homo sapiens created opportunities for exchange, interbreeding, and perhaps cultural learning. Competition added pressure in landscapes that could no longer support everyone equally. And across many generations, Neanderthal communities became fewer, more isolated, and less able to recover from loss. Then, as a distinct human people, they were gone, but not entirely. Their bones remain in caves and sediments. Their tools remain in ancient soil. Their DNA remains in small pieces, in many living people today. Not enough to make us Neanderthals, but enough to remind us that their story continued through families, through children, through descendants who may never have known the full history carried in their cells. For a long time, the world held many human worlds. Different bodies, different landscapes, different memories of winter, fire, animals, rivers, and home. Now only one human species remains. That does not make the others unreal, primitive, or defeated. It makes their absence more meaningful, and their traces, however faint, more precious. If you enjoyed this quiet journey into the Neanderthal world, please like, comment, and subscribe. Let me know where you are listening from tonight. And if you would like to support the channel in the best possible way, listen on Spotify. The link is waiting in the description. For now, rest easy. Somewhere beneath the soil, beside the ash of an old fire, the human worlds that came before us are still waiting to be remembered.